Principles of Geology, or The Modern Changes of the Earth and Its Inhabitants Considered as Illustrative of Geology, by Sir Charle Lyell, M.A., F.R.S. Preface to the 9th edition. The Principles of Geology in the first 5 editions embrace not only a view of the modern changes of the Earth and its inhabitants, as set forth in the present work, but also some account of those monuments of analogous changes of ancient date, both in the organic and inorganic world, which it is the business of the geologist to interpret. The subject last mentioned, or geology proper, constituted originally a 4th book, now omitted, the same having been enlarged into a separate treatise, first published in 1838 in 1 volume, and called The Elements of Geology, afterwards recast in 2 volumes in 1842 and again re-edited under the title Manual of Elementary Geology in 1 volume in 1851. The principles and manual thus divided occupy, with one exception to which I shall presently allude, very different ground. The principles treat of such portions of the economy of existing nature, animate and inanimate, as are illustrative of geology, so as to comprise an investigation of the permanent effects of causes now in action, which may serve as records to after ages of the present condition of the globe and its inhabitants. Such effects are the enduring monuments of the ever-varying state of the physical geography of the globe, the lasting signs of its destruction and renovation, and the memorials of the equally fluctuating condition of the organic world. They may be regarded, in short, as a symbolical language, in which the Earth's autobiography is written. In the Manual of Elementary Geology, on the other hand, I have treated briefly of the component materials of the Earth's crust, their arrangement and relative position, and their organic contents, which, when deciphered by aid of the key supplied to the study of the modern changes above alluded to, reveal to us the annals of a grand succession of past events, a series of revolutions which the solid exterior of the globe and its living inhabitants have experienced in some antecedent to the creation of man. In thus separating the 2 works, however, I have retained in the Principles, Book 1, the discussion of some matters which might fairly be regarded as common to both treatises, as, for example, an historical sketch of the early progress of geology, followed by a series of preliminary essays to explain the facts and arguments which lead me to believe that the forces now operating upon and beneath the Earth's surface may be the same, both in kind and degree, as those which at remote epochs have worked out geological changes. See Analysis of Contents of this work, page 9. If I am asked whether the principles or the manual should be studied first, I feel much the same difficulty in answering the questions as if a student should inquire whether he ought to take up first a treatise on chemistry or one on natural philosophy, subjects sufficiently distinct yet inseparably connected. On the whole, while I have endeavored to make each of the 2 treatises in their present form quite independent of the other, I would recommend the reader to study first the modern changes of the Earth and its inhabitants as they are discussed in the present volume, proceeding afterwards to the classification and interpretation of the monuments of more remote ages. Chapter 1. Geology is the science which investigates the successive changes that have taken place in the organic and inorganic kingdoms of nature. It inquires into the causes of these changes and the influence which they have exerted in modifying the surface and external surface structure of our planet. By these researches into the state of the Earth and its inhabitants at former periods, we acquire a more perfect knowledge of its present condition, and more comprehensive views concerning the laws now governing its animate and inanimate productions. When we study history, we obtain a more profound insight into human nature, by instituting a comparison between the present and former states of society. We trace the long series of events which have gradually led to the actual posture of affairs, and by connecting effects with their causes, we are enabled to classify and retain in the memory a multitude of complicated relations, the various peculiarities of national character, the different degrees of moral and intellectual refinement, and numerous other circumstances, which, without historical associations, would be uninteresting or imperfectly understood. As the present condition of nations is a result of many antecedent changes, some extremely remote, and others recent, some gradual, others sudden and violent, so the state of the natural world is a result of long successions of events, and if we should enlarge our experience of the present economy of nature, we must investigate the effects of her operations in former epochs. We often discover with surprise, on looking back into the chronicles of nations, how the fortune of some battle has influenced the fate of millions of our contemporaries, when it has long been forgotten by the mass of the population. With this remote event, we may find inseparably connected the geographical boundaries of a great state, the language now spoken by the inhabitants, their peculiar manners, laws, and religious opinions. But far more astonishing and unexpected are the connections brought to light when we carry back our researches into the history of nature. The form of a coast, the configuration of the interior of a country, the existence and extent of lakes, valleys, and mountains, can often be traced to the former prevalence of earthquakes and volcanoes in regions which have long been undisturbed. To these remote convulsions, the present fertility of some districts, the sterile character of others, the elevation of land above the sea, the climate, and various peculiarities may be distinctly referred. On the other hand, many distinguishing features of the surface may often be ascribed to the operation, at a remote era, of slow and tranquil causes, to the gradual deposition of sediment in a lake or in the ocean, or to the prolific increase of testacea and corals. To select another example, we find in certain localities subterranean deposits of coal, consisting of vegetable matter, formerly drifted into seas and lakes. These seas and lakes have since filled up, the lands whereon the forest grew have disappeared or changed their form, the rivers and currents which floated the vegetable masses can no longer be traced, and the plants belonging to the species for which ages have passed away from the surface of our planet. Yet the commercial prosperity, the numerical strength of a nation, may now be mainly dependent on the local distribution of fuel determined by that ancient state of things. Geology is intimately related to almost all the physical sciences, as history is to the moral. An historian should, if possible, be at once profoundly acquainted with ethics, politics, jurisprudence, the military art, theology, in a word, all the branches of knowledge by which any insight into human affairs or into the moral and intellectual nature of man can be obtained. It would be no less desirable that a geologist should be well versed in chemistry, natural philosophy, mineralogy, zoology, comparative anatomy, botany, in short, in every science relating to organic and inorganic nature. With these accomplishments, the historian and geologist would rarely fail to draw correct and philosophical conclusions from the various monuments transmitted to them of former occurrences. They would know to what combination of causes analogous effects were referable, and they would often be enabled to supply, by inference, information concerning many events unrecorded in the defective archives of former ages. But as such extensive acquisitions are scarcely within the reach of any individual, it is necessary that men who have devoted their lives to different departments should unite their efforts, and as the historian receives assistance from the antiquary and from those who have cultivated different branches of moral and political science, so the geologist should avail himself to the aid of many naturalists, and particularly of those who have studied the fossil remains of lost species of animals and plants. The analogy, however, of the monuments consulted in geology and those available in history extends no farther than to one class of historical monuments, those which may be said to be undesignedly commemorative of former events. The canoes, for example, the stone hatchets found in our peat bogs, afford an insight into the rude arts and manners of the earliest inhabitants of our island. The buried coin fixes the date of the reign of some Roman emperor. The ancient encampment indicates the districts once occupied by invading armies, and the former method of constructing military defenses. The Egyptian mummies throw light on the art of embalming, the rites of sepulture, or the average stature of the human race in ancient Egypt. This class of memorials yields to no other in authenticity, but it constitutes a small part only of the resources on which the historian relies, whereas in geology it forms the only kind of evidence which is at our command. For this reason, we must not expect to obtain a full and connected account of any series of events beyond the reach of history. But the testimony of geological monuments, if frequently imperfect, possess at least the advantage of being free from all intentional misrepresentation. We may be deceived in the inferences which we draw, in the same manner as we often mistake the nature and import of phenomena observed in the daily course of nature. But our liability to err is confined to the interpretation, and, if this be correct, our information is certain. It was long before the distinct nature and legitimate objects of geology were fully recognized, and it was at first confounded with many other branches of inquiry, just as the limits of history, poetry, and mythology were ill-defined in the infancy of civilization. Even in Werner's time, or at the close of the 18th century, geology appears to have been regarded as little other than a subordinate department of mineralogy, and Desmarest included it under the head of physical geography. But the most common and serious source of confusion arose from the notion that it was the business of geology to discover the mode in which the earth originated, or, as some imagined, to study the effects of those cosmological causes which were employed by the author of nature to bring this planet out of a nascent and chaotic state into a more perfect and habitable condition. Hutton was the first who endeavored to draw a strong line of demarcation between his favorite science and cosmogony, for he declared that geology was in no wise concerned, quote, with questions as to the origin of things, end quote. An attempt will be made in the sequel of this work to demonstrate that geology differs as widely from cosmogony as speculations concerning the mode of the first creation of man differ from history. But before entering more at large on this controverted question, it will be desirable to trace the progress of opinion on this topic from the earliest ages to the commencement of the present century. Chapter 2. Historical Sketch of the Progress of Geology. Oriental Cosmogony. The earliest doctrines of the Indian and Egyptian schools of philosophy agreed in ascribing the first creation of the world to an omnipotent and infinite being. They concurred also in representing this being, who had existed from all eternity, as having repeatedly destroyed and reproduced the world and all its inhabitants. In the sacred volume of the Hindus, called the Ordinances of Minu, comprising the Indian system of duties, religious and civil, we find a preliminary chapter treating of the creation, in which the cosmogony is known to have been derived from earlier writings and traditions, and principally from certain hymns of high antiquity called the Vedas. These hymns were first put together, according to Mr. Colebrook, in a connected series about 13 centuries before the Christian era, but they appear from internal evidence to have been written at various antecedent periods. In them, as we learn from the researches of Professor Wilson, the eminent Sanskrit scholar, two distinct philosophical systems are discoverable. According to one of them, all things were originally brought into existence by the sole will of a single first cause, which existed from eternity. According to the other, there have always existed two principles, the one material, but without form, the other spiritual and capable of compelling inert matter to develop its sensible properties. This development of matter into, quote, individual and visible existences, end quote, is called creation, and is assigned to a subordinate agent, or the creative faculty of the Supreme Being embodied in the person of Brahma. In the first chapter of the Ordinances of Minu, above alluded to, we meet with the following passages related to former destructions and renovations of the world. Quote, the being, whose powers are incomprehensible, having created me, Minu, and this universe, again became absorbed in the Supreme Spirit, changing the time of energy for the hour of repose. When that power awakes, then has this world its full expansion, but when he slumbers with a tranquil spirit, then the whole system fades away. For while he reposes, as it were, embodied spirits endowed with principle of action depart from their several acts, and the mind itself becomes inert. End quote. The absorption of all beings into the supreme essence is then described, and the divine soul itself is said to slumber, and to remain for a time immersed in, quote, the first idea, or in darkness, end quote. After which the text thus proceeds, verse 57, quote, thus that immutable power by waking and reposing alternately revivifies and destroys, in eternal succession, this whole assemblage of locomotive and immovable creatures, end quote. It is then declared that there has been a long succession of manvantaras, or periods, each of the duration of many thousand ages, and, quote, there are creations also and destructions of worlds innumerable. The being, supremely exalted, performs all this with as much ease as if in sport, again and again, for the sake of conferring happiness. End quote. No part of the Eastern cosmogony, from which these extracts are made, is more interesting to the geologist than the doctrine so frequently alluded to of the reiterated submersion of the land beneath the waters of a universal ocean. In the beginning of things, we are told, the first sole cause, quote, with a thought created the waters, end quote, and then moved upon their surface on the form of Brahma the Creator, by whose agency the emergence of the dry land was effected, and the peopling of the earth with plants, animals, celestial creatures, and man. Afterwards, as often as a general conflagration at the close of each manvantara had annihilated every visible and existing being, Brahma, on awakening from his sleep, finds the whole world a shapeless ocean. Accordingly, in the legendary poems called the Puranas, composed at a later date than the Vedas, the first three avatars or descents of the deity upon earth have for their object to recover the land from the waters. For this purpose, Vishnu is made successively to assume the form of a fish, a tortoise, and a boar. Extravagant as may be some of the conceits and fictions which disfigure these pretended revelations, we can by no means look upon them as a pure effort of the unassisted imagination, or believe them to have been composed without regard to opinions and theories founded on the observation of nature. In astronomy, for instance, it is declared that at the North Pole, the year was divided into a long day and night, and that their long day was the northern, and their night the southern course of the sun. And to the inhabitants of the moon, it is said one day is equal to the length of 1 month of mortals. If such statements cannot be resolved into mere conjectures, we have no right to refer to mere chance the prevailing notion that the earth and its inhabitants had formerly undergone a succession of revolutions and aqueous catastrophes interrupted by long intervals of tranquility. Now there are two sources in which such a theory may have originated. The marks of former convulsions in every part of the surface of our planet are obvious and striking. The remains of marine animals embedded in the solid strata are so abundant that they may be expected to force themselves on the attention of every people who have made some progress in refinement. And especially where one class of men are expressly set apart from the rest, like the ancient priesthoods of India and Egypt, for study and contemplation. If these appearances are once recognized, it seems natural that the mind should conclude in favor not only of mighty changes in past ages, but of alternate periods of repose and disorder. Of repose when the animals now fossil lived, grew, and multiplied. Of disorder when a strata in which they were buried became transferred from the sea to the interior of continents, and were uplifted so as to form part of a high mountain chains. These modern writers, who are disposed to disparage the former intellectual advancement and civilizations of Eastern nations, may concede some foundation of observed facts for the curious theories now under consideration, without indulging in exaggerated opinions of the progress of science. Especially as universal catastrophes of the world and exterminations of organic beings, in the sense in which they were understood by the Brahmins, are untenable doctrines. We know that the Egyptian priests were aware not only that the soil beneath the plains of the Nile, but also that the hills bounding the Great Valley contained marine shells. And Herodotus inferred from these facts that all Lower Egypt, and even the highlands above Memphis, had once been covered by the sea. As similar fossil remains occur in all parts of Asia hitherto explored, far in the interior of the continent as well as near the sea, they could hardly have escaped detection by some Eastern sages not less capable than the Greek historian of reasoning philosophically on natural phenomena. We also know that the rulers of Asia were engaged in very remote eras in executing great national works, such as tanks and canals, requiring extensive excavations. In the 14th century of our era, in the year 1360, the removal of soil necessary for such undertakings brought to light geological facts which attracted the attention of a people less civilized than were many of the older nations of the East. The historian Farishta relates that 50,000 laborers were employed in cutting through a mound so as to form a junction between the rivers Salima and Sutlej, and in this mound were found the bones of elephants and men, some of them petrified and some of them resembling bone. The gigantic dimensions attributed to the human bones show them to have belonged to some of the larger pachydermata. But, although the Brahmins, like the priests of Egypt, may have been acquainted with the existence of fossil remains and strata, it is possible that the doctrine of successive destructions and renovations of the world merely received corroboration from such proofs, and that it may have originally been handed down, like the religious traditions of most nations, from a ruder state of society. The system may have had its source, in part at least, in exaggerated accounts of those dreadful catastrophes which are occasioned by particular combinations of natural causes. Floods and volcanic eruptions, the agency of water and fire, are the chief instruments of devastation on our globe. We shall point out in the sequel the extent of many of these calamities, recurring at distant intervals of time in the present course of nature, and shall only observe here that they are so peculiarly calculated to inspire a lasting terror, and are so often fatal in their consequences to great multitudes of people, that it scarcely requires the passions for the marvelous, so characteristic of rude and half-civilized nations, still less the exuberant imagination of Eastern writers, to augment them into general cataclysms and conflagrations. The great flood of the Chinese, which their traditions carry back to the period of Yao, something more than 2,000 years before our era, has been identified by some persons with the universal deluge described in the Old Testament. But according to Mr. Davis, who accompanied 2 of our embassies to China, and who has carefully examined their written accounts, the Chinese cataclysm is therein described as interrupting the business of agriculture, rather than as involving a general destruction of the human race. The great Yu was celebrated for having, quote, opened 9 channels to draw off the waters, end quote, which, quote, covered the low hills and bathed the foot of the highest mountains, end quote. Mr. Davis suggests that a great derangement of waters of the Yellow River, one of the largest in the world, might even now cause the flood of the Yao to be repeated, and laid the most fertile and populous plains of China under water. In modern times, the bursting of the banks of an artificial canal, into which a portion of the Yellow River has been turned, has repeatedly given rise to the most dreadful accidents, and is a source of perpetual anxiety to the government. It is easy, therefore, to imagine how much greater may have been the inundation if this valley was ever convulsed by a violent earthquake. Humboldt relates the interesting fact that, after the annihilation of a large part of the inhabitants of Cumana by an earthquake in 1766, a season of extraordinary fertility ensued, in consequence of the great rains which accompanied the subterranean convulsions. Quote, "The Indians," he says, "celebrated after the ideas of antique superstition, by festivals and dancing, the destruction of the world and the approaching epoch of its regeneration." End quote. The existence of such rites among the rude nations of South America is most important, as showing what effects may be produced by local catastrophes, recurring at distant intervals of time, on the minds of barbarous and uncultivated race. I shall point out in the sequel how the tradition of a deluge among Araucanian Indians may be explained by reference to great earthquake waves which have repeatedly rolled over part of Chile since the first recorded flood of 1590. See Chapter 29, Book 2. The legend also of the ancient Peruvians of an inundation many years before the reign of the Incas, in which only 6 persons were saved on a float, relates to a region which has more than once been overwhelmed by inroads of the ocean since the days of Pizarro. Chapter 29, Book 2. I might refer to the reader to my account of the submergence of a wide area in Kutch so lately as the year 1819, when a single tower only of the fort of Sindri appeared above the waste of waters, if it were necessary, to prove how easily the catastrophes of modern times might give rise to traditionary narratives among a rude people of floods of boundless extent. Nations without written records, and who are indebted for all their knowledge of past events exclusively to oral tradition, are in the habit of confounding in one legend a series of incidents which may have happened at various epochs. Nor must we forget that the superstitions of a savage tribe are transmitted through all the progressive stages of society, till they exert a powerful influence on the mind of the philosopher. He may find, in the monuments of former changes on the earth's surface, an apparent confirmation of tenets handed down through successive generations, from the rude hunter, whose terrified imagination drew a false picture of those awful visitations of floods and earthquakes, whereby the whole earth as known to him was simultaneously devastated. Egyptian Cosmogony. Respecting the cosmogony of the Egyptian priests, we gather much information from the writers of the Grecian sects, who borrowed almost all of their tenets from Egypt, and amongst others that of the former successive destruction and renovation of the world. We learn from Plutarch that this was the theme of one of the hymns of Orpheus, so celebrated in the fabulous ages of Greece. It was brought by him from the banks of the Nile, and we even find in his verses, as in the Indian systems, a definite period assigned for the duration of each successive world. The returns of great catastrophes were determined by the periods of the Annus Magnus, or Great Year, a cycle composed of the revolutions of the sun, moon, and the planets, and terminating when these returned together to the same sign whence they were supposed at some remote epoch to have set out. The duration of this great cycle was variously estimated. According to Orpheus, it was 120,000 years. According to others, 300,000, and by Cassander it was taken to be 360,000 years. We learn particularly from the Timaeus of Plato that the Egyptians believed the world to be subject to occasional conflagrations and deluges, whereby the gods arrested the career of human wickedness and purified the earth from guilt. After each regeneration, mankind were in a state of virtue and happiness, from which they gradually degenerated again into vice and immorality. From this Egyptian doctrine, the poets derived the fable of the decline from the Golden to the Iron Age. The sect of Stoics adopted most fully the system of catastrophes destined by certain intervals to destroy the world. Those they taught were of 2 kinds: the cataclysm, or destruction by water, which sweeps away the whole human race and annihilates all the animal and vegetable products of nature, and the ekpyrosis, or destruction by fire, which dissolves the globe itself. From the Egyptians also they derived the doctrine of the gradual debasement of man from a state of innocence. Towards the termination of each era, the gods could no longer bear with the wickedness of men, and a shock of the elements or a deluge overwhelmed them, after which calamity Astrea again descended on the earth to renew the Golden Age. The connection between the doctrine of successive catastrophes and repeated deteriorations in moral character of the human race is more intimate and natural than might at first be imagined. For in a rude state of society, all great calamities are regarded by the people as judgments of God on the wickedness of man. Thus, in our own time, the priests persuaded a large part of the population of Chile, and perhaps believed themselves, that the fatal earthquake of 1822 was a sign of the wrath of heaven for the great political revolution just then consummated in South America. In like manner, in the account given by Solon by the Egyptian priests of the submersion of the island of Atlantis under the waters of the ocean after repeated shocks of an earthquake, we find that the event happened when Jupiter had seen the moral depravity of the inhabitants. Now, when the notion had once gained ground, whether from causes before suggested or not, that the earth had been destroyed by several general catastrophes, it would next be inferred that the human race had been as often destroyed and renovated. And since every extermination was assumed to be penal, it could only be reconciled with divine justice by the supposition that man, at each successive creation, was regenerated in a state of purity and innocence. A very large portion of Asia, inhabited by the earliest nations, whose traditions have come down to us, has been always subject to tremendous earthquakes. Of the geographical boundaries of these and their effects, I shall speak in the proper place. Egypt has, for the most part, been exempt from this scourge, and the Egyptian doctrine of great catastrophes has probably derived in part, as before hinted, from early geological observations and in part from Eastern nations. Pythagorean doctrines. Pythagoras, who resided for more than 20 years in Egypt, and according to Cicero had visited the East and conversed with the Persian philosophers, introduced into his own country, on his return, the doctrine of the gradual deterioration of the human race from an original state of virtue and happiness. But if we are to judge of his theory concerning the destruction and renovation of the earth from the sketch given by Ovid, we must concede it to have been far more philosophical than any known version of the cosmogonies of Oriental or Egyptian sects. Although Pythagoras is introduced by the poet as delivering his doctrine in person, some of the illustrations are derived from natural events which happened after the death of the philosopher. But notwithstanding these anachronisms, we may regard the account as a true picture of the tenets of the Pythagorean school in the Augustan age, and although perhaps partially modified, it must have contained the substance of the original scheme. Thus considered, it is extremely curious and instructive, for we here find a comprehensive summary of almost all the great causes of change now in activity on the globe, and these adduced in confirmation of a principle of a perpetual and gradual revolution inherent in the nature of our terrestrial system. These doctrines, it is true, are not directly applied to the explanation of geological phenomena, or, in other words, no attempt is made to estimate what may have been in past ages, or what may hereafter be, the aggregate amount of change brought by such never-ending fluctuations. Had this been the case, we might have been called upon to admire so extraordinary an anticipation with no less interest than astronomers, when they endeavor to define by what means the Samian philosopher came to the knowledge of the Copernican system. Let us examine the celebrated passages to which Let us now examine the celebrated passages to which we have been adverting. Quote, "Nothing perishes in this world, but things merely vary and change their form. To be born means simply that a thing begins to be something different from what it was before, and dying is ceasing to be the same thing. Yet, although nothing retains long the same image, the sum of the whole remains constant." End quote. These general propositions are then confirmed by a series of examples, all derived from natural appearances, except the first, which refers to the Golden Age giving place to the Age of Iron. The illustrations are thus consecutively adduced. 1. Solid land has been converted into sea. 2. Sea has been changed into land. Marine shells lie far distant from the deep, and the anchor has been found on the summit of hills. 3. Valleys have been excavated by running water, and floods have washed down hills into the sea. 4. Marshes have become dry ground. 5. Dry lands have been changed into stagnant pools. 6. During earthquakes, some springs have been closed up and new ones have broken out. Rivers have deserted their channels and may have been reborn elsewhere, as the Erasinus in Greece and the Mysis in Asia. 7. The waters of some rivers, formerly sweet, have become bitter, as those of the Anagris in Greece, etc. 8. Islands have become connected with the mainland by growth of deltas and new deposits, as in the case of Antissa joined to Lesbos, Pharos to Egypt, etc. 9. Peninsulas have been divided from the mainland, and have become islands, as Leucadia, and according to tradition, Sicily, the sea having carried away the isthmus. 10. Land has been submerged by earthquakes. The Grecian cities of Hellas and Beirut, for example, are to be seen under the sea with their walls inclined. 11. Plains have been upheaved into hills by the confined air seeking vent, as at Triazine in the Peloponnesus. 12. The temperature of some springs varies at different periods. The waters of others are inflammable. 13. There are streams which have a petrifying power, and convert the substances which they touch into marble. 14. Extraordinary medicinal and deleterious effects are produced by the water of different lakes and springs. 15. Some rocks and islands, after floating and having been subject to violent movements, have at length become stationary and immovable, as Delos in the Cyanean Isles. 16. Volcanic vents shift their position. There was a time when Etna was not a burning mountain, and the time will come when it will cease to burn, whether it be that some caverns become closed up by the movements of the earth and others opened, or whether the fuel is finally exhausted, etc., etc. The various causes of change in the inanimate world having been thus enumerated, the doctrine of equivocal generation is next propounded, as illustrating a corresponding perpetual flux in the animate creation. In the Egyptian and Eastern cosmogonies, and in the Greek version of them, no very definite meaning can, in general, be attached to the term, quote, destruction of the world, end quote. For sometimes it would seem almost to imply the annihilation of our planetary system, and at others a mere revolution of the surface of the earth. Opinions of Aristotle. From the works now extant of Aristotle, and from the system Pythagoras, as above exposed, we might certainly infer that these philosophers considered the agents of change now operating in nature as capable of bringing about in the lapse of ages a complete revolution, and the Stagirite even considers occasional catastrophes happening at distant intervals of time as part of the regular and ordinary course of nature. The deluge of Deucalion, he says, affected Greece only, and principally the part called Hellas, and it arose from great inundations of rivers during a rainy winter. But such extraordinary winters, he says, though after a certain period they return, do not always revisit the same places. Censorinus quotes it as Aristotle's opinion that there were general inundations of the globe, and that they alternated with conflagrations, and that the flood constituted the winter of the great year or astronomical cycle, while the conflagration or destruction by fire is the summer or period of greatest heat. If this passage, as Lipsius supposes, be an amplification, by Censorinus, of what was written in the Meteoritics, it is a gross misrepresentation of the doctrine of the Stagirite, for the general bearing of his reasoning in that treatise tends clearly in an opposite direction. He refers to many examples of changes now constantly going on, and insists emphatically on the great results which they must produce in the lapse of ages. He instances particular cases of lakes that had dried up and deserts that had at length become watered by rivers and fertilized. He points to the growth of the Nilotic delta since the time of Homer, to the shallowing of the Peleus Moeotis within 60 years from his own time, and although in the same chapter he says nothing of earthquakes, yet in others of the same treatise he shows himself not unacquainted with their effects. He alludes, for example, to the upheaving of one of the Aeolian Islands previous to a volcanic eruption. Quote, the changes of the earth, he says, are so slow in comparison to the duration of our lives that they are overlooked, and the migrations of people after great catastrophes and their removal to other regions causes the event to be forgotten. End quote. When we consider the acquaintance displayed by Aristotle in his various works with the destroying and renovating powers of nature, the introductory and concluding passages of the 12th chapter of his Meteoritics are certainly very remarkable. In the first sentence he says, quote, the distribution of land and sea in particular regions does not endure throughout all time, but it becomes sea in those parts where it was land, and again it becomes land where it was sea. And there is reason for thinking that these changes take place according to a certain system and within a certain period. End quote. The concluding observation is as follows, quote, as time never fails and the universe is eternal, neither the Tanais nor the Nile can have flowed forever. The places where they rise were once dry, and there is a limit to their operations, but there is none to time. So also of all other rivers, they sprung up and they perish. And the sea also continually deserts some lands and invades others. The same tracts, therefore, of the earth are not, some always sea, and others always continents, but everything changes in the course of time. End quote. It seems then that the Greeks had not only derived from preceding nations, but had also, in some slight degree, deduced from their own observations, the theory of periodical revolutions in the inorganic world. There is, however, no ground for imagining that they contemplated former changes in the races of animals and plants. Even the fact that marine remains were enclosed in solid rocks, although observed by some, and even made the groundwork of geological speculation, never stimulated the industry or guided the inquiries of naturalists. It is not impossible that the theory of equivocal generation might have engendered some indifference on this subject, and that a belief in the spontaneous production of living beings from the earth or corrupt matter might have caused the organic world to appear so unstable and fluctuating that phenomena indicative of former changes would not awaken intense curiosity. The Egyptians, it is true, had taught, and the Stoics had repeated, that the earth had once given birth to some monstrous animals, which existed no longer. But the prevailing opinion seems to have been that after each great catastrophe the same species of animals were created over again. This tenet is implied in the passage of the Seneca, where, speaking of a future deluge, he says, quote, "Every animal shall be generated anew, and man free from guilt shall be given to the earth." End quote. An old Arabian version of the doctrine of the successive revolutions of the globe, translated by Abraham Ecchellensis, seems to form a singular exception to the general rule. For here we find the idea of different genera and species having been created. The Gerbonites, a sect of astronomers who flourished some centuries before the Christian era, taught as follows, quote, that after every period of 36,425 years, there were produced a pair of every species of animal, both male and female, from whom animals might be propagated and inhabit this lower world. But when a circulation of the heavenly orbs was completed, which is finished in that space of years, other genera and species of animals are propagated, as also of plants and other things, and the first order is destroyed, and so it goes on forever and ever. End quote. Theory of Strabo. As we learn much of the tenets of the Egyptian and Oriental schools in the writings of the Greeks, so many speculations of the early Greek authors are made known to us in the works of the Augustan and later ages. Strabo, in particular, enters largely, in the second book of his geography, into the opinions of Eratosthenes and other Greeks on one of the most difficult problems in geology, viz., by what causes marine shells came to be plentifully buried in the earth at such great elevations and distances from the sea. He notices, amongst others, the explanation of Xanthus the Lydian, who said that the seas had once been more extensive and that they had afterwards been partially dried up, as in his own time many lakes, rivers, and wells in Asia had failed during a season of drought. Treating this conjecture with merited disregard, Strabo passes on to the hypothesis of Strato, the natural philosopher, who had observed that the quantity of mud brought down by the rivers into the Euxine was so great that its bed must be gradually raised, while the rivers still continued to pour in an undiminished quantity of water. He, therefore, conceived that originally, when the Euxine was an inland sea, its level had by this means become so much elevated that it burst its barrier near Byzantium and formed a communication with the Propontis, and this partial drainage, he supposed, had already converted the left side into marshy ground, and thus, at last, the whole world would be choked up with soil. So, it was argued, the Mediterranean had once opened a passage for itself by the columns of Hercules into the Atlantic, and perhaps the abundance of seashells in Africa, near the temple of Jupiter Ammon, might also be the deposit of some former inland sea, which had at length forced a passage and escaped. But Strabo rejects this theory as insufficient to account for all the phenomena, and he proposes one of his own, the profoundness of which modern geologists are only beginning to appreciate. Quote, "It is not because the lands covered by the seas were originally at different altitudes, that the waters have risen or subsided or receded from some parts and inundated others, but the reason is that the same land is sometimes raised up and sometimes depressed, and the sea also is simultaneously raised and depressed, so that it either overflows or returns into its own place again. We must, therefore, ascribe the cause to the ground, either to that ground which is under the sea, or to that which becomes flooded by it, but rather to that which lies beneath the sea, for this is more movable and, on account of its humidity, can be altered with great celerity." End quote. He observes in continuation, quote, "It is proper to derive our explanations from things which are obvious, and in some measure of daily occurrence, such as deluges, earthquakes, and volcanic eruptions, and sudden swellings of the land beneath the sea, for they raise up the sea also, and when the same land subside again, they occasion the sea to be let down, and it is not merely the small, but the large islands also, and not merely the islands, but the continents which can be lifted up together with the sea, and both large and small tracts may subside, for habitations and cities like Bure, Bazona, and many others have been engulfed by earthquakes." End quote. In another place, this learned geographer, in alluding to the tradition that Sicily had been separated by convulsions from Italy, remarks that at present the land near the sea in those parts was rarely shaken by earthquakes, since there were now open orifices whereby fire and ignited matters and water escape. But formerly, when the volcanoes of Etna, the Lipari Islands, Ischia, and others were closed up, the imprisoned fire and wind might have produced far more vehement movements. The doctrine, therefore, that volcanoes are safety valves, and that the subterranean convulsions are probably most violent when first the volcanic energy shifts itself to a new quarter, is not modern. We learn from a passage in Strabo that it was a dogma of the Gaulish Druids that the universe was immortal, but destined to survive catastrophes both of fire and water. That this doctrine was communicated to them from the East, with much of their learning, cannot be doubted. Caesar, it will be remembered, says that they made use of Greek letters in arithmetical computations. Pliny. This philosopher had no theoretical opinions of his own concerning changes of the earth's surface, and in this department, as in others, he restricted himself to the task of a compiler without reasoning on the facts stated by him or attempting to digest them into regular order. But his enumeration of the new islands which had been formed in the Mediterranean and of other convulsions shows that the ancients had not been inattentive observers of the changes which had taken place within the memory of man. Such, then, appear to have been the opinions entertained before the Christian era concerning the past revolutions of our globe. Although no particular investigations had been made for the express purpose of interpreting the monuments of ancient changes, they were too obvious to be entirely disregarded, and the observations of the present course of nature presented too many proofs of alterations continually in progress on the earth to allow philosophers to believe that nature was in a state of rest, or that the surface had remained and would continue to remain unaltered. But they had never compared attentively the results of the destroying and reproductive operations of modern times with those of remote eras, nor had they ever entertained so much as a conjecture concerning the comparative antiquity of the human race, or of living species of animals and plants, with those belonging to former conditions of the organic world. They had studied the movements and positions of the heavenly bodies with laborious industry, and made some progress in investigating the animal, vegetable, and mineral kingdoms, but the ancient history of the globe was to them a sealed book, and, although written in characters of the most striking and imposing kind, they were unconscious even of its existence. End chapter 2. Chapter 3. History of the Progress of Geology, continued. Arabian writers. After the decline of the Roman Empire, the cultivation of physical science was first revived with some success by the Saracens, about the middle of the 8th century of our era. The works of the most eminent classic writers were purchased at great expense from the Christians, and translated into Arabic, and Al-Mamun, son of the famous Harun al-Rashid, the contemporary of Charlemagne, received with marks of distinction, at his court at Baghdad, astronomers and men of learning from different countries. This caliph, and some of his successors, encountered much opposition and jealousy from the doctors of the Mahometan law, who wished the Muslims to confine their study of the Quran, dreading the effects of the diffusion of a taste for the physical sciences. Avicenna. Almost all the works of the early Arabian writers are lost. Amongst those of the 10th century, of which fragments are now extant, is a short treatise, quote, on the formation and classification of minerals, end quote, by Avicenna, a physician in whose arrangement there is considerable merit. The second chapter, on the cause of mountains, is remarkable, for mountains, he says, are formed by some essential, others by accidental causes. In illustration of the essential, he instances, quote, a violent earthquake, by which land is elevated and becomes a mountain, end quote. Of the accidental, the principle, he says, is excavation by water, whereby cavities are produced and adjoining lands made to stand out and form eminences. Omar, the cosmogony of the Quran. In the same century, also, Omar, surnamed El-Alem, or the Learned, wrote a work on the retreat of the sea. It appears that on comparing the charts of his own time with those made by the Indian and Persian astronomers 2,000 years before, he had satisfied himself that important changes had taken place since the times of history in the form of the coasts of Asia, and that the extension of the sea had been greater at some former periods. He was confirmed in this opinion by the numerous salt springs and marshes in the interior of Asia, a phenomenon from which Pallas, in more recent times, has drawn the same inference. Van Hoff has suggested, with great probability, that the changes in the level of the Caspian, some of which there is reason to believe have happened within the historical era, and the geological appearances in that district, indicating the desertion by that sea of its ancient bed, had probably led Omar to his theory of a general subsidence. But whatever may have been the proofs relied on, his system was declared contradictory to certain passages in the Quran, and he was called upon publicly to recant his errors, to avoid which prosecution he went into voluntary banishment from Samarkand. The cosmological opinions expressed in the Quran are few and merely introduced incidentally, so that it is not easy to understand how they could have interfered so seriously with the free discussion on the former changes of the globe. The prophet declares that the earth was created in 2 days, and the mountains were then placed on it, and during these 2 additional days the inhabitants of the earth were formed, and in 2 more the 7 heavens. There is no more detail of circumstances, and the deluge, which is also mentioned, is discussed with equal brevity. The waters are represented to have poured out of an oven, a strange fable said to be borrowed from the Persian Magi, who represented them as issuing from the oven of an old woman. All men were drowned, save Noah and his family, and then God said, quote, "O earth, swallow up thy waters, and thou, O heaven, withhold thy rain," end quote. And immediately the waters abated. We may suppose Omar to have represented the desertion of the land by the sea to have been gradual, and that his hypothesis required a greater lapse of ages than was constant with the Muslim orthodoxy, for it is to be inferred from the Quran that man and this planet were created at the same time, and although Muhammad did not limit expressly the antiquity of the human race, yet he gave an implied sanction to the Mosaic chronology by the veneration expressed by him for the Hebrew patriarchs. A manuscript work, entitled The Wonders of Nature, is preserved in the Royal Library at Paris by an Arabian writer, Muhammad Qazwini, who flourished in the 7th century of the Hegira, or at the close of the 13th century of our era. Besides several curious remarks on aerolites, earthquakes, and the successive changes of position which the land and sea have undergone, we meet with the following beautiful passage which is given as the narrative of Kids, an allegorical personage. Quote, "I passed one day by a very ancient and wonderfully populous city, and asked one of its inhabitants how long it had been founded. 'It is indeed a mighty city,' replied he. 'We know not how long it has existed, and our ancestors were on this subject as ignorant as ourselves. 5 centuries afterwards, as I passed by the same place, I could not perceive the slightest vestige of the city. I demanded of a peasant, who was gathering herbs upon this former site, how long it had been destroyed. 'In sooth, a strange question,' replied he. 'The ground here has never been different from what you now behold it. Was there not of old,' said I, 'a splendid city here?' 'Never,' answered he, 'so far as we have seen, and never did our fathers speak to us of any such.' On my return there 500 years afterwards, I found the sea in the same place, and on its shores were a party of fishermen, of whom I inquired how long the land had been covered by the waters. 'Is this a question,' said they, 'for a man like you? The spot has always been what it is now.' I again returned 500 years afterwards, and the sea had disappeared. I inquired of a man who stood alone upon the spot how long ago this change had taken place, and he gave me the same answer as I had received before. Lastly, on coming back again after an equal lapse of time, I found there a flourishing city, more populous and more rich in beautiful buildings than the city I had seen the first time, and when I would fain have informed myself concerning its origin, the inhabitants answered me, 'Its rise is lost in remote antiquity. We are ignorant how long it has existed, and our fathers were on this subject as ignorant as ourselves.'" End quote. Early Italian writers. It was not till the earlier part of the 16th century that geological phenomena began to attract the attention of the Christian nations. At that period, a very animated controversy sprang up in Italy concerning the true nature and origin of marine shells and other organized fossils found abundantly in the strata of the peninsula. The celebrated painter Leonardo da Vinci, who in his youth had planned and executed some navigable canals in the north of Italy, was one of the first to apply sound reasoning to those subjects. The mud of rivers, he said, had covered and penetrated into the interior of fossil shells at a time when these were still at the bottom of the sea near the coast. Quote, "They tell us that these shells were formed in the hills by the influence of the stars, but I ask where in the hills are the stars now forming shells of distinct ages and species? And how can the stars explain the origin of gravel, occurring at different heights and composed of pebbles rounded as if by the motion of running water? Or in what manner can such a cause account for the petrification in some places of various leaves, seaweeds, and marine crabs?" End quote. The excavations made in 1517 for repairing the city of Verona brought to a light a multitude of curious petrifications and furnished matter for speculation to different authors, and among the rest to Fracastoro, who declared his opinion that fossil shells had belonged to living animals, which had formerly lived and multiplied where the exuviae are now found. He exposed the absurdity of having recourse to a certain plastic force, which it was said had power to fashion stones into organic forms, and with no less cogent arguments demonstrated the futility of attributing the situation of the shells in question to the Mosaic deluge, a theory obstinately defended by some. That inundation, he observed, was too transient. It consisted principally of fluviatile waters, and if it had transported shells to great distances, must have strewed them over the surface, not buried them at vast depths in the interior of mountains. His clear exposition of the evidence would have terminated the discussion forever if the passions of mankind had not been enlisted in the dispute, and even though doubts should for a time have remained in some minds, they would speedily have been removed by the fresh information obtained almost immediately afterwards respecting the structure of fossil remains and their living analogues. But the clear and philosophical views of Fracastoro were disregarded, and the talent and argumentative powers of the learned were doomed for 3 centuries to be wasted in the discussion of these 2 simple and preliminary questions. First, whether fossil remains had ever belonged to living creatures, and secondly, whether, if this be admitted, all the phenomena could not be explained by the deluge of Noah. It had been the general belief of the Christian world down to the period now under consideration that the origin of this planet was not more remote than a few thousand years, and that since the creation the deluge was the only great catastrophe by which considerable change had been wrought on the earth's surface. On the other hand, the opinion was scarcely less general that the final dissolution of our system was an event to be looked for at no distant period. The era, it is true, of the expected millennium had passed away, and for 500 years after the fatal hour when the annihilation of the planet had been looked for, the monks remained in undisturbed enjoyment of rich grants of land bequeathed to them by pious donors, who, in the preamble of deeds beginning, quote, "A propinquante mundi termino," end quote, "A propinquante magno judici die," end quote, left lasting monuments of the popular delusion. But although in the 16th century it had become necessary to interpret certain prophecies respecting the millennium more liberally, and to assign a more distant date to the future conflagration of the world, we find in the speculations of the early geologists perpetual allusion to such an approaching catastrophe, while in all that regarded the antiquity of the earth, no modification whatever of the opinions of the Dark Ages had been effected. Considerable alarm was at first excited when the attempt was made to invalidate by physical proofs an article of faith so generally received, but there was sufficient spirit of toleration and candor amongst the Italian ecclesiastics to allow the subject to be canvassed with much freedom. They even entered warmly into the controversy themselves, often favoring different sides of the question, and however much we may deplore the loss of time and labor devoted to the defense of untenable positions, it must be conceded that they displayed far less polemic bitterness than certain writers who followed them, quote, "beyond the Alps," end quote, 2 centuries and a half later. Controversy as to the real nature of fossil organic remains. Mattioli Falloppio, the system of scholastic disputations encouraged in the universities of the Middle Ages, had unfortunately trained men to habits of indefinite argumentation, and they often preferred absurd and extravagant propositions because the greater skill was required to maintain them, the end and object of these intellectual combats being victory and not truth. No theory could be so far-fetched or fantastical as not to attract some followers, provided it fell in with popular notions. And as cosmogonists were not at all restricted in building their systems to the agency of known causes, the opponents of Fracastoro met his arguments by feigning imaginary causes, which differed from each other rather in name than in substance. Andrea Mattioli, for instance, an eminent botanist, the illustrator of Dioscorides, embraced the notion of Agricola, a skillful German miner, that a certain, quote, "materia pinguis," end quote, or, quote, "fatty matter," end quote, set into fermentation by heat gave birth to fossil organic shapes. Yet Mattioli had come to the conclusion from his own observations that porous bodies such as bones and shells might be converted into stone, as being permeable to what he termed the, quote, "lapidifying juice," end quote. In like manner, Falloppio of Padua conceived that petrified shells were generated by fermentation in the spots where they are found, or that they had in some cases acquired their form from, quote, "the tumultuous movement of terrestrial exhalations." Although celebrated as a professor of anatomy, he taught that certain tusks of elephants dug up in his time in Apulia were merely earthy concretions, and consistently with these principles, he even went so far as to consider it probable that the vases of Monte Testaceo of Rome were natural impressions stamped in the soil. In the same spirit, Mercati, who published in 1574 faithful figures of the fossil shells preserved by Pope Sixtus V in the Museum of the Vatican, expressed an opinion that they were mere stones, which had assumed their peculiar configuration from the influence of the heavenly bodies. And Olivai of Cremona, who described the fossil remains of a rich museum at Verona, was satisfied with considering them as mere, quote, sports of nature, end quote. Some of the fanciful notions of these times were deemed less unreasonable, as being somewhat in harmony with the Aristotelian theory of spontaneous generation, then taught in all the schools. For men who had been taught in early youth that a large proportion of living animals and plants was formed from the fortuitous concourse of atoms, or had sprung up from the corruption of organic matter, might easily persuade themselves that organic shapes, often imperfectly preserved in the interior of solid rocks, owed their existence to causes equally obscure and mysterious. Cardano, 1552. But there were not wanting some who, during the progress of this century, expressed more sound and sober opinions. The title of a work of Cardano's, published in 1552, De Subtilitate, corresponding to what now would be called transcendental philosophy, would lead us to expect in the chapter on minerals many far-fetched theories characteristic of that age. But when treating of petrified shells, he decided that they clearly indicated the former sojourn of the sea upon the mountains. Cesalpino Maggioli, 1597. Cesalpino, a celebrated botanist, conceived that fossil shells had been left on the land by a retiring sea, and had concreted into stone during the same consolidation of the soil. And in the following year, 1597, Simeone Maggioli went still further, and, coinciding for the most part with the views of Cesalpino, suggested that the shells and submarine matter of the Veronese and other districts might have been cast upon the land by volcanic explosions, like those which gave rise in 1538 to Monte Nuovo, near Puzioli. This hint seems to have been the first imperfect attempt to connect the position of fossil shells with the agency of volcanoes, a system afterwards more fully developed by Hooke, Lazzaro Moro, Hutton, and other writers. 2 years afterwards, Imperati advocated the animal origin of fossilized shells, yet admitted that stones could vegetate by force of, quote, an internal principle, end quote, and as evidence of this, he referred to the teeth of fish and spines of echini found petrified. Palissy, 1580. Palissy, a French writer on the origin of springs from rainwater, and of other scientific works, undertook in 1580 to combat the notions of many of his contemporaries in Italy that petrified shells had all been deposited by the universal deluge. Quote, he was the first, end quote, said Fontenelle, when in the French Academy he pronounced his eulogy nearly a century and a half later, quote, who dared assert, end quote, in Paris that fossil remains of testacea and fish had once belonged to marine animals. Fabio Colonna. To enumerate the multitude of Italian writers who advanced various hypotheses, all equally fantastical, in the early part of the 17th century would be unprofitably tedious. But Fabio Colonna deserves to be distinguished, for, although he gave way to the dogma that all fossil remains were to be referred to the deluge of Noah, he resisted the absurd theory of Stelluti, who taught that fossil wood and ammonites were mere clay, altered into such forms by sulphurous waters and subterranean heat. And he pointed out the different states of shells buried in the strata, distinguishing between, first, the mere mold or impression, second, the cast or nucleus, and thirdly, the remains of the shell itself. He had also the merit of being the first to point out that some of the fossils had belonged to marine and some to terrestrial testacea. Steno, 1669. But the most remarkable of that period was published by Steno, a Dane, once professor of anatomy at Padua, and who afterwards resided many years at the court of the Grand Duke of Tuscany. His treatise bears the quaint title of De Solido Intra Solidum Naturaliter Contento, 1669, by which the author intended to express, quote, on gems, crystals, and organic petrifications enclosed within solid rocks, end quote. This work attests the priority of the Italian school in geological research, exemplifying at the same time the powerful obstacles opposed in that age to the general reception of enlarged views in the science. It was still a favorite dogma that the fossil remains of shells and marine creatures were not of animal origin, an opinion adhered to by many from their extreme reluctance to believe that the earth could have been inhabited by living beings before a great part of the existing mountains were formed. In reference to this controversy, Steno had dissected a shark recently taken from the Mediterranean and had demonstrated that its teeth and bones were identical with many fossils found in Tuscany. He had also compared the shells discovered in the Italian strata with living species, pointed out their resemblance, and traced the various gradations from shells merely calcined, or which had only lost their animal gluten, to those petrifications in which there was a perfect substitution of stony matter. In his division of mineral masses, he insisted on the secondary origin of those deposits in which the spoils of animals or fragments of older rocks were enclosed. He distinguished between marine formations and those of a fluviatile character, the last containing reeds, grasses, or the trunks and branches of trees. He argued in favor of the original horizontality of sedimentary deposits, attributing their present inclined and vertical positions sometimes to the escape of subterranean vapors, heaving the crusts of the earth from below upwards, and sometimes to the falling in of masses overlying subterranean cavities. He declared that he had obtained proof that Tuscany must successively have acquired 6 distinct configurations, having been twice covered by water, twice laid dry with a level, and twice with an irregular and uneven surface. He displayed great anxiety to reconcile this new views with Scripture, for which purpose he pointed to certain rocks as having been formed before the existence of animals and plants. Selecting unfortunately as examples certain formations of limestone and sandstone in his own country, now known to contain, although sparingly, the remains of animals and plants, strata which do not even rank as the oldest part of our secondary series. Steno suggested that Moses, when speaking of the loftiest mountains as having been covered by the deluge, meant merely the loftiest of the hills then existing, which may not have been very high. The diluvian waters, he supposed, may have been issued from the interior of the earth into which they had retired, when in the beginning the land was separated from the sea. These and other hypotheses on the same subject are not calculated to enhance the value of the treatise, and could scarcely fail to detract from the authority of those opinions which were sound and legitimate deductions from fact and observation. They have served, nevertheless, as the germs of many popular theories of later times, and in an expanded form have been put forth as original inventions by some of our contemporaries. Sylla, 1670. Sylla, a Sicilian painter, published in 1670 a treatise in Latin on the fossils of Calabria, illustrated by good engravings. This work proves the continued ascendancy of dogmas often refuted, for we find the wit and eloquence of the author chiefly directed against the obstinate incredulity of naturalists as to the organic nature of fossil shells. Like many eminent naturalists of his day, Sylla gave way to the popular persuasion that all fossil shells were the effects and proofs of the Mosaic deluge. It may be doubted whether he was perfectly sincere, and some of his contemporaries who took the same course were certainly not so. But so eager were they to root out what they justly considered an absurd prejudice respecting the nature of organized fossils, that they seem to have been ready to make any concessions in order to establish this preliminary point. Such a compromising policy was short-sighted, since it was to little purpose that the nature of the documents should at length be correctly understood, if men were prevented from deducing fair conclusions from them. Diluvial theory. The theologians who now entered the field in Italy, Germany, France, and England were innumerable, and henceforward they who refused to subscribe to the position that all marine organic remains were proofs of the Mosaic deluge were exposed to the imputation of disbelieving the whole of the sacred writings. Scarcely any step had been made in approximating to sound theories since the time of Fracastoro, more than 100 years having been lost in writing down the dogma that organized fossils were mere sports of nature. An additional period of a century and a half was now destined to be consumed in exploding the hypothesis that organized fossils had all been buried in the solid strata by Noah's flood. Never did a theoretical fallacy in any branch of science interfere more seriously with accurate observation and the systematic classification of facts. In recent times, we may attribute our rapid progress chiefly to the careful determination of the order of succession in mineral masses by means of their different organic contents and their regular superposition. But the old diluvialists were induced by their system to confound all the groups of strata together instead of discriminating, to refer all appearances to one cause and to one brief period, not to a variety of causes acting throughout a long succession of epochs. They saw the phenomena only as they desired to see them, sometimes misrepresenting facts and at other times deducing false conclusions from correct data. Under the influence of such prejudices, 3 centuries were of as little avail as a few years in our own times, when we are no longer required to propel the vessel against the force of an adverse current. It may be well, therefore, to forewarn the reader that in tracing the history of geology from the close of the 17th to the end of the 18th century, he must expect to be occupied with accounts of the retardation as well as of the advance of the science. It will be necessary to point out the frequent revival of exploded errors and the relapse from sound to the most absurd opinions, and to dwell on futile reasoning and visionary hypotheses, because some of the most extravagant systems were invented or controverted by men of acknowledged talent. In short, a sketch of the progress of geology is the history of a constant and violent struggle of new opinions against doctrines sanctioned by the implicit faith of many generations, and supposed to rest on scriptural authority. The inquiry, therefore, although highly interesting to one who studies the philosophy of the human mind, is too often barren of instruction to him who searches for truths in physical science. Quirini, 1676. Quirini, in 1676, contended, in opposition to Sylla, that the diluvian waters could not have conveyed heavenly bodies to the summit of mountains, since the agitation of the sea never, as Boyle had demonstrated, extended to great depths. And still less could the testacea, as some pretended, have lived in these diluvian waters, for, quote, the duration of the flood was brief, and the heavy rains must have destroyed the saltiness of the sea, end quote. He was the first writer who ventured to maintain that the universality of the Mosaic cataclysm ought not to be insisted upon. As to the nature of petrified shells, he conceived that as earthly particles united in the sea to form the shells of mollusca, the same crystallizing process might be effected on the land. In that, in the latter case, the germs of the animals might have been disseminated through the substance of the rocks, and afterwards developed by virtue of humidity. Visionary as was this doctrine, it gained many proselytes even amongst the more sober reasoners of Italy and Germany, for it conceded that the position of fossil bodies could not be accounted for by the diluvial theory. Plot Lister, 1678. In the meantime, the doctrine that fossil shells had never belonged to real animals maintained its ground in England, where the agitation of the question began at a much later period. Dr. Plot, in his Natural History of Oxfordshire, 1677, attributed to a, quote, plastic virtue latent in the earth, end quote, the origin of fossil shells and fishes, and Lister, to his accurate account of British shells, in 1678, added the fossil species under the appellation of turbinated and bivalve stones. He said, quote, either these were terrigenous, or if otherwise, the animals they so exactly represent have become extinct, end quote. This writer appears to have been the first who was aware of the continuity over large districts of the principal groups of strata in the British series, and who proposed the construction of regular geological maps. Leibniz, 1680. The great mathematician Leibniz published his Protegea in 1680. He imagined this planet to have been originally a burning luminous mass, which ever since its creation has been undergoing refrigeration. When the outer crust had cooled down sufficiently to allow the vapors to be condensed, they fell and formed a universal ocean, covering the loftiest mountains and investing the whole globe. The crust, as it is consolidated from a state of fusion, assumed a vesicular and cavernous structure, and being rent in some places, allowed the water to rush into subterranean hollows, whereby the level of the primeval ocean was lowered. The breaking in of these vast caverns is supposed to have given rise to the dislocated and deranged position of the strata, quote, which Steno had described, end quote, and the same disruptions communicated violent movements to the incumbent waters, whence great inundations ensued. The waters, after they had been thus agitated, deposited their sedimentary matter during intervals of quiescence, and hence the various stony and earthy strata. Says Leibniz, quote, we may recognize, therefore, a double origin of primitive masses, the one by refrigeration from igneous fusion, the other by concretion from aqueous solution, end quote. By the repetition of similar causes, the disruption of the crust and consequent floods, alternations of new strata were produced until at length these causes were reduced to a condition of quiescent equilibrium, and a more permanent state of things was established. Hooke, 1688. The posthumous works of Robert Hooke, M.D., well known as a general mathematician and natural philosopher, appeared in 1705, containing a discourse on earthquakes, which we are informed by his editor was written in 1668, but revised at subsequent periods. Hooke frequently refers to the best Italian and English authors who wrote before his time on geological subjects, but there are no passages in his works implying that he participated in the enlarged views of Steno and Lister, or of his contemporary Woodward, in regard to the geographical extent of certain groups of strata. His treatise, however, is the most philosophical production of that age, in regard to the causes of former changes in organic and inorganic kingdoms of nature. He says, quote, "However trivial a thing a rotten shell may appear to some, yet these monuments of nature are more certain tokens of antiquity than coins or medals, since the best of those may be counterfeited or made by art and design, as may also books, manuscripts, and inscriptions, as all the learned are now sufficiently satisfied as often been actually practiced." End quote. And continues, quote, "And though it must be granted that this is very difficult to read them, of the records of nature, and to raise a chronology out of them, and to state at the intervals of the time wherein such or such catastrophes and mutations have happened, yet it is not impossible." End quote. Respecting the extinction of species, Hooke was aware that the fossil ammonites, nautili, and many other shells and fossil skeletons found in England were of different species from any then known, but he doubted whether the species had become extinct, observing that the knowledge of naturalists of all the marine species, especially those inhabiting the deep sea, was very deficient. In some parts of his writings, however, he leans to the opinion that species had been lost, and in speculating on this subject, he even suggests that there might be some connection between the disappearance of certain kinds of animals and plants and the changes wrought by earthquakes in former ages. Some species, he observes with great sagacity, are, quote, "peculiar to certain places, and not to be found elsewhere. If, then, such a place had been swallowed up, it is not improbable but that those animate beings may have been destroyed with it. And this may be true both of aerial and aquatic animals, for those animated bodies, whether vegetables or animals, which were naturally nourished or refreshed by the air, would be destroyed by the water." End quote. Turtles, he adds, and such large ammonites as are found in Portland, seem to have been the products of hotter countries, and it is necessary to suppose that England once lay under the sea within the torrid zone. To explain this and similar phenomena, he indulges in a variety of speculations concerning the changes in the position of the axis of the Earth's rotation, quote, "a shifting of the Earth's center of gravity analogous to the revolutions of the magnetic pole." End quote. None of these conjectures, however, are proposed dogmatically, but rather in the hope of promoting fresh inquiries and experiments. In opposition to the prejudices of his age, we find him arguing against the idea that nature had formed fossil bodies, quote, "for no other end than to play the mimic in the animal kingdom," end quote. Maintaining that figured stones were, quote, "really the several bodies they represent, or the moldings of them petrified," end quote, and not, as some have imagined, a lusus naturae, sporting herself in the needless formation of useless beings. It was objected to Hooke that his doctrine of the extinction of species derogated from the wisdom and power of the omnipotent Creator, but he answered that, as individuals die, there may be some termination to the duration of a species, and his opinions, he declared, were not repugnant to Holy Writ, for the Scriptures taught that our system was degenerating and tending to its final dissolution. Quote, "And as, when that shall happen, all the species will be lost, why not some at one time and some at another?" End quote. But his principal object was to account for the manner in which shells had been conveyed into the higher parts of, quote, "the Alps, Apennines, and Pyrenean hills, and the interior of continents in general." End quote. These and other appearances, he said, might have been brought about by earthquakes, quote, "which have turned plains into mountains, and mountains into plains, seas into land, and land into seas, made rivers where there were none before, and swallowed up others that formerly were, etc., etc., and which, since the creation of the world, have wrought many great changes on the superficial parts of the earth, and have been the instruments of placing shells, bones, plants, fishes, and the like, in those places where, with much astonishment, we find them." End quote. This doctrine, it is true, had been laid down in terms almost equally explicit by Strabo to explain the occurrence of fossil shells in the interior of continents, and to that geographer and other writers of antiquity Hooke frequently refers. But the revival and development of the system was an important step in the progress of modern science. Hooke enumerated all the examples known to him of subterranean disturbance, from, quote, "the sad catastrophe of Sodom and Gomorrah," end quote, down to the Chilean earthquake of 1646. The elevating of the bottom of the sea, the sinking and submersion of the land, and most of the inequalities of the earth's surface might, he said, be accounted for by the agency of those subterranean causes. He mentions that the coast near Naples was raised during the eruption of Monte Nuovo, and that in 1591 land rose in the island of St. Michael during an eruption. And although it would be more difficult, he says, to prove, he does not doubt but that there had been as many earthquakes in the parts of the earth under the ocean as in the parts of the dry land. in confirmation of which he mentions the immeasurable depth of the sea near some volcanoes. To attest the extent of simultaneous subterranean movements, he refers to an earthquake in the West Indies in the year 1690, where the space of earth raised or, quote, struck upwards, end quote, by the shock exceeded, he affirms, the length of the Alps and Pyrenees. Hooke's diluvial theory. As Hooke declared the favorite hypothesis of the day, quote, that marine fossil bodies were to be referred to Noah's flood, end quote, to be wholly untenable, he appears to have felt himself called upon to substitute a diluvial theory of his own, and thus he became involved in countless difficulties and contradictions. He said, quote, during the great catastrophe, there might have been a changing of that part which was before dry land into sea by sinking, and of that which was sea into dry land by raising, and marine bodies might have been buried in sediment beneath the ocean, as in the interval between the creation and the deluge, end quote. Then follows a disquisition on the separation of the land from the waters mentioned in Genesis, during which operation some places of the shell of the earth were forced outwards and others pressed downwards or inwards, etc. His diluvial hypothesis very much resembles that of Steno, and was entirely opposed to the fundamental principles professed by him, that he would explain the former changes of the earth in a more natural manner than others had done. When, in despise of his declaration, he required a former, quote, crisis of nature, end quote, and taught that earthquakes had become debilitated and that the Alps, Andes, and other chains had been lifted up in a few months, he was compelled to assume so rapid a rate of change that his machinery appeared scarcely less extravagant than that of his most fanciful predecessors. For this reason, perhaps, his whole theory of earthquakes met with undeserved neglect. Ray, 1692. One of his contemporaries, the celebrated naturalist, Ray, participated in the same desire to explain geological phenomena by reference to causes less hypothetical than those usually resorted to. In his essay on Chaos and Creation, he proposed a system agreeing in its outline and in many of the details with that of Hooke, but his knowledge of natural history enabled him to elucidate the subject with various original observations. Earthquakes, he suggested, might have been the second causes employed at the creation, in separating the land from the waters, and in gathering the waters together into one place. He mentions, like Hooke, the earthquakes of 1646, which had violently shaken the Andes for some hundreds of leagues, and made many alterations therein. In assigning a cause for the general deluge, he preferred a change in the Earth's center of gravity to the introduction of earthquakes. Some unknown cause, he said, might have forced the subterranean waters outwards, as was perhaps indicated by, quote, the breaking up of the fountains of the great deep, end quote. Ray was one of the first of our writers who enlarged upon the effects of running water upon land, and of the encroachment of the sea upon the shores. So important did he consider the agency of these causes, that he saw in them an indication of the tendency of our system to its final dissolution, and he wondered why the earth did not proceed more rapidly towards a general submersion beneath the sea, when so much matter was carried down by rivers or undermined in the sea cliffs. We perceive clearly from his writings that the gradual decline of our system and its future consummation by fire was held to be as necessary an article of faith by the orthodox, as was the recent origin of our planet. His discourses, like those of Hooke, are highly interesting, as attesting the familiar association in the minds of philosophers in the age of Newton of questions in physics and divinity. Ray gave an unequivocal proof of the sincerity of his mind by sacrificing his preferment in the Church rather than take an oath against the Covenanters, which he could not reconcile with his conscience. His reputation, moreover, in the scientific world placed him high above the temptation of courting popularity by pandering to the physico-theological taste of his age. It is, therefore, curious to meet with so many citations from the Christian fathers and prophets in his essays on physical science, to find him in one page proceeding by the strict rules of induction to explain the former changes of the globe, and in the next gravely entertaining the question whether the sun and stars and the whole heavens shall be annihilated together with the earth at the era of the grand conflagration. Woodward, 1695. Among the contemporaries of Hooke and Ray, Woodward, a professor of medicine, had acquired the most extensive information respecting the geological structure of the crust of the earth. He had examined many parts of the British strata with minute attention, and his systematic collection of specimens, bequeathed to the University of Cambridge, and still preserved there as arranged by him, shows how far he had advanced in ascertaining the order of superposition. From the great number of facts collected by him, we might have expected his theoretical views to be more sound and enlarged than those of his contemporaries. But in his anxiety to accommodate all observed phenomena to the scriptural account of the creation and deluge, he arrived at most erroneous results. He conceived, quote, the whole terrestrial globe to have been taken to pieces and dissolved at the flood, and the strata to have settled down from this promiscuous mass as any earthy sediment from a fluid, end quote. In corroboration of these views, he insisted upon the fact that, quote, marine bodies are lodged in the strata according to the order of their gravity, the heavier shells in stone, the lighter in chalk, and so of the rest, end quote. Ray immediately exposed the unfounded nature of this assertion, remarking truly that fossil bodies, quote, are often mingled, heavy with light, in the same stratum, end quote. And he even went so far as to say that Woodward, quote, must have invented the phenomena for sake of confirming his bold and strange hypothesis, end quote. A strong expression from the pen of a contemporary. Burnet, 1690. At the same time, Burnet published his Theory of the Earth. The title is most characteristic of the age. The sacred theory of the earth, containing an account of the original of the earth, and of all the general changes which it hath already undergone, or is to undergo, till the consummation of all things. Even Milton had scarcely ventured in his poem to indulge his imagination so freely in painting scenes of the creation and deluge, paradise and chaos. He explained why the primeval earth enjoyed a perpetual spring before the flood, showed how the crust of the globe was fissured by, quote, the sun's rays, end quote, so that it burst, and thus the diluvial waters were let loose from a supposed central abyss. Not satisfied with these themes, he derived from the books of the inspired writers, and even from heathen authorities, prophetic views of the future revolutions of the globe, gave a most terrific description of the general conflagration, and proved that a new heaven and a new earth will rise out of a second chaos, after which will follow the blessed millennium. The reader should be informed that, according to the opinion of many respectable writers of that age, there was good scriptural ground for presuming that the garden bestowed upon our first parents was not on the earth itself, but above the clouds, in the middle region between our planet and the moon. Burnet approaches with becoming gravity the discussion of so important a topic. He was willing to concede that the geographical position of paradise was not in Mesopotamia, yet he maintained that it was upon the earth and in the southern hemisphere, near the equinoctial line. Butler selected this conceit as a fair mark for his satire when, amongst the numerous accomplishments of Hudibras, he says, quote, he knew the seat of paradise, could tell in what degree it lies, and as he was disposed, could prove it below the moon or else above it, end quote. Yet the same monarch, who is said never to have slept without Butler's poem under his pillow, was so great an admirer and patron of Burnet's book that he ordered it to be translated from Latin into English. The style of this sacred theory was eloquent, and the book displayed powers of invention of no ordinary stamp. It was, in fact, a fine historical romance, as Buffon afterwards declared. It was treated as a work of profound science in the time of its author, and was panegyrized by Addison in a Latin ode, while Steele praised it in The Spectator. Whiston, 1696. Another production of the same school, and equally characteristic of the time, was that of Whiston, entitled A New Theory of the Earth, wherein the creation of the world in 6 days, the universal deluge, and the general conflagration as laid down in the Holy Scriptures are shown to be perfectly agreeable to reason and philosophy. He was at first a follower of Burnet, but his faith in the infallibility of that writer was shaken by the declared opinion of Newton that there was every presumption in astronomy against any former change in the inclination of the Earth's axis. This was a leading dogma in Burnet's system, though not original, for it was borrowed from an Italian, Alessandro degli Alessandri, who had suggested it in the beginning of the 15th century to account for the former occupation of the present continents by the sea. Laplace has since strengthened the arguments of Newton against the probability of any former revolution of this kind. The remarkable comet of 1680 was fresh in the minds of everyone when Whiston first began his cosmological studies, and the principal novelty of his speculations consisted in attributing the deluge to the near approach to the earth of one of these erratic bodies. Having ascribed an increase of the waters to this source, he adopted Woodward's theory, supposing all stratified deposits to have resulted from, quote, chaotic sediment of the flood, end quote. Whiston was one of the first who ventured to propose that the text of Genesis should be interpreted differently from its ordinary acceptation, so that the doctrine of the earth having existed long previous to the creation of man might no longer be regarded as unorthodox. He had the art to throw in an air of plausibility over the most improbable parts of his theory, and seemed to be proceeding in the most sober manner, and, by the aid of his mathematical demonstration, to the establishment of his various propositions. Locke pronounced a panegyric of his theory, commending him for having explained so wonderful and before inexplicable things. His book, as well as Burnet's, was attacked and refuted by Kyle. Like all those who introduced purely hypothetical causes to account for natural phenomena, Whiston retarded the progress of truth, diverting men from the investigation of the laws of sublunary nature and inducing them to waste time in speculations on the powers of comets to drag the waters of the ocean over land, on the condensation of the vapors of their tails into water, and other matters equally edifying. Hutchinson, 1724. John Hutchinson, who had been employed by Woodward in making his collection of fossils, published afterwards in 1724 the first part of his Moses's Principia, wherein he ridiculed Woodward's hypothesis. He and his numerous followers were accustomed to declaim loudly against human learning, and they maintained that the Hebrew Scriptures, when rightly translated, comprised a perfect system of natural philosophy, for which reason they objected to the Newtonian theory of gravitation. Celsius. Andreas Celsius, the Swedish astronomer, published about this time his remarks on the gradual diminution and sinking of the waters in the Baltic, to which I have the occasion to advert more particularly in the sequel, Chapter 29. Schweitzer, 1708. In Germany, in the meantime, Schweitzer published his Complaint and Vindication of the Fishes, 1708, Piscium Querelae et Vindiciae, a work of zoological merit, in which he gave some good plates and descriptions of fossil fish. Among other conclusions, he labored to prove that the earth had been remodeled at the deluge. Pluche, also in 1732, wrote to the same effect, while Holbach, in 1753, after considering the various attempts to refer all ancient formations to the flood of Noah, exposed the inadequacy of this cause. Italian geologists. Vallisneri. I return with pleasure to the geologists of Italy, who preceded, as has already been shown, the naturalists of other countries in their investigations into the ancient history of the earth, and who also still maintained a decided preeminence. They refuted and ridiculed the physico-theological systems of Burnet, Whiston, and Woodward, while Vallisneri, in his comments on the Woodwardian theory, remarked how much the interests of religion as well as those of sound philosophy had suffered by perpetually mixing up the sacred writings with questions in physical science. The works of this author were rich in original observations. He attempted the first general sketch of the marine deposits of Italy, their geographical extent, and most characteristic organic remains. In his treatise On the Origin of Springs, he explained their dependence on the order, and often on the dislocations, of the strata, and reasoned philosophically against the opinions of those who regarded the disordered state of the earth's crust as exhibiting signs of the wrath of God for the sins of man. He found himself under the necessity of contending in his preliminary chapter against St. Jerome, and 4 other principal interpreters of Scripture, besides several professors of divinity, quote, that springs did not flow by subterranean siphons and cavities from the sea upwards, losing their saltiness in the passage, end quote, for this theory had been made to rest on the infallible testimony of Holy Writ. Although reluctant to generalize on the rich materials accumulated in his travels, Vallisneri had been so much struck by the remarkable continuity of the more recent marine strata, from one end of Italy to the other, that he came to the conclusion that the ocean formerly extended over the whole earth, and after abiding there for a long time, had gradually subsided. His opinion, however untenable, was a great step beyond Woodward's diluvian hypothesis, against which Vallisneri, and after him all the Tuscan geologists, uniformly contended, while it was warmly supported by the members of the Institute of Bologna. Among others of that day, Spada, a priest of Grassana, in 1737, wrote to prove that the petrified marine bodies near Verona were not diluvian. Mattani drew a similar inference from the shells of Volterra and other places, while Constantini, on the other hand, whose observations on the valley of the Brenta and other districts were not without value, undertook to vindicate the truth of the deluge, as also to prove that Italy had been peopled by the descendants of Japhet. Moro, 1740. Lazzaro Moro, in his work, published in 1740, on the marine bodies which are found in the mountains, attempted to apply the theory of earthquakes as expounded by Strabo, Pliny, and other ancient authors with whom he was familiar, to the geological phenomena described by Vallisneri. His attention was awakened to the elevating power of subterranean forces by a remarkable phenomenon which happened in his own time, and which had also been noticed by Vallisneri in his letters. A new island rose in 1707 from the deep water in the Gulf of Santorin, in the Mediterranean, during continued shocks of an earthquake, and, increasing rapidly in size, grew in less than a month to be half a mile in circumference and about 25 feet above high water mark. It was soon afterwards covered by volcanic ejections, but, when first examined, it was found to be a white rock bearing on its surface living oysters and crustacea. In order to ridicule the various theories then in vogue, Morrow ingeniously supposes the arrival on this new island of a party of naturalists ignorant of its recent origin. One immediately points to the marine shells as proofs of the universal deluge. Another argues that they demonstrate the former residence of the sea upon the mountains. A third dismisses them as mere sports of nature, while the fourth affirms that they were born and nourished within the rock in ancient caverns into which salt water had been raised in the shape of vapor by action of subterranean heat. Morrow pointed with great judgment to the faults and dislocations of the strata described by Vallisneri in the Alps and other chains in confirmation of his doctrine, that the continents had been heaved up by subterranean movements. He objected, on solid grounds, to the hypothesis of Burnet and of Woodward, yet he ventured so far to disregard the protest of Vallisneri as to undertake the adaptation of every part of his own system to the Mosaic account of the creation. On the third day, he said, the globe was everywhere covered to the same depth by fresh water, and when it pleased the Supreme Being that the dry land should appear, volcanic explosions broke up the smooth and regular surface of the earth composed of primary rocks. These rose in mountain masses above the waves and allowed melted metals and salts to ascend through fissures. The sea gradually acquired its saltiness from volcanic exhalations, and while it became more circumscribed in area, increased in depth. Sand and ashes ejected by the volcanoes were regularly disposed along the bottom of the ocean and formed the secondary strata, which in their turn were lifted up by earthquakes. We need not follow this author in tracing the progress of the creation of vegetables and animals on the other days of creation, but upon the whole it may be remarked that few of the old cosmological theories had been conceived with so little violation of known analogies. Generali's Illustrations of Morrow, 1749. The style of Morrow was extremely prolix, and like Hutton, who at a later period advanced many of the same views, he stood in need of an illustrator. The Scotch geologist was hardly more fortunate in the advocacy of Playfair than was Morrow in numbering amongst his admirers Cirillo Generelli, who, 9 years afterwards, delivered at a sitting of academicians at Cremona a spirited exposition of his theory. This learned Carmelitan friar does not pretend to have been an original observer, but he had studied sufficiently to enable him to confirm the opinions of Morrow by arguments from other writers. And this selection of the doctrines then best established is so judicious that a brief abstract of them cannot fail to be acceptable, as illustrating the state of geology in Europe, and in Italy in particular, before the middle of the last century. The bowels of the earth, says he, have carefully preserved the memorials of past events, and this truth the marine productions so frequent in the hills attest. From the reflections of Lazzaro Morrow, we may assure ourselves that these are the effects of earthquakes in past times, which have changed vast spaces of sea into terra firma, and inhabited lands into seas. In this, more than in any other department of physics, are observations and experiments indispensable, and we must diligently consider facts. The land is known, wherever we make excavations, to be composed of different strata or soils placed one above the other, some of sand, some of rock, some of chalk, others of marl, coal, pumice, gypsum, lime, and the rest. These ingredients are sometimes pure and sometimes confusedly intermixed. Within are often imprisoned different marine fishes, like dried mummies, and more frequently shells, crustacea, corals, plants, etc., not only in Italy, but in France, Germany, England, Africa, Asia, and America. Sometimes in the lowest, sometimes in the loftiest beds of the earth, and some upon the mountains, some in deep mines, others near the sea, and others hundreds of miles distant from it. Woodward conjectured that these marine bodies might be found everywhere, but there are rocks in which none of them occur, as is sufficiently attested by Vallisneri and Marsili. The remains of fossil animals consist chiefly of their more solid parts, and the most rocky strata must have been soft when such exuviae were enclosed in them. Vegetable productions are often in different states of maturity, indicating that they were embedded in different seasons. Elephants, elks, and other terrestrial quadrupeds have been found in England and elsewhere in superficial strata never covered by the sea. Alternations are rare, yet not without example, of marine strata with those which contain marshy and terrestrial productions. Marine animals are arranged in the subterraneous beds with admirable order, in distinct groups, oysters here, dentalia or corals there, etc., as now, according to Marsili, on the shores of the Adriatic. We must abandon the doctrine, once so popular, which denies that organized fossils were derived from living beings, and we cannot account for their present position by the ancient theory of Strabo, nor by that of Leibniz, nor by the universal deluge as explained by Woodward and others. Quote, "Nor is it reasonable to call the deity capriciously upon the stage, and to make him work miracles for the sake of confirming our preconceived hypothesis." End quote. Quote, "I hold in utter abomination, most learned academicians, those systems which are built upon their foundations in the air, and cannot be propped up without a miracle, and I undertake, with the assistance of Morrow, to explain to you how these marine animals were transported into the mountains by natural causes." End quote. A brief abstract then follows of Morrow's theory, by which, says Generelli, we may explain all the phenomena, as Vallisneri so ardently desired, quote, "without violence, without fictions, without hypothesis, without miracles." End quote. The Carmelitan then proceeds to struggle against an obvious objection to Morrow's system, considered as a method of explaining the revolutions of the earth naturally. If earthquakes have been the agents of such mighty changes, how does it happen that their effects since the times of history have been so inconsiderable? The same difficulty had, as we have seen, presented itself to Hooke, half a century before, and forced him to resort to a former, quote, "crisis of nature," end quote. But Generelli defended his position by showing how numerous were the accounts of eruptions and earthquakes, of new islands, and of elevations and subsidences of the land, and yet how much greater a number of like events must have been unattested and unrecorded during the last 6,000 years. He also appealed to Vallisneri as an authority to prove that the mineral masses containing shells bore, upon the whole, but a small proportion to those rocks which were destitute of organic remains, and the latter, says the learned monk, might have been created as they now exist, in the beginning. Generelli then describes the continual waste of mountains and continents by the action of rivers and torrents, and concludes with these eloquent and original observations. Quote, "Is it possible that this waste should have continued for 6,000 and perhaps a greater number of years, and that the mountain should remain so great unless their ruins have been repaired? Is it credible that the author of nature should have founded the world upon such laws, as that the dry land should forever be growing smaller and at last become wholly submerged beneath the waters? Is it credible that, amid so many created things, the mountains alone should daily diminish in number and bulk without there being any repair of their losses? This would be contrary to that order of providence which is seen to reign in all other things in the universe. Wherever I deem it is just to conclude that the same cause which, in the beginning of time, raised mountains from the abyss, has down to the present day continued to produce others, in order to restore from time to time the losses of all such as sink down in different places, or are rent asunder, or in other ways suffer disintegration. If this be admitted, we can easily understand why there should now be found upon many mountains so great a number of crustacea and other marine animals." End quote. In the above extract, I have not merely enumerated the opinions and facts which are confirmed by recent observation, suppressing all that has since proved to be erroneous, but have given a faithful abridgment of the entire treatise, with the omission only of Morrow's hypothesis, which Generelli adopted, with all its faults and excellences. The reader will therefore remark that although this admirable essay embraces so large a portion of the principal objects of geologic research, it makes no allusion to the extinction of certain classes of animals, and it is evident that no opinions on this head had, at the time, gained a firm footing in Italy. That Lister and other English naturalists would long before have declared in favor of the loss of species, while Sylla and most of his countrymen hesitated, was perhaps natural, since the Italian museums were filled with fossil shells belonging to species of which a great portion did actually exist in the Mediterranean, whereas the English collectors could obtain no recent species from such of their own strata as were then explored. The weakest point in Morrow's system consisting in deriving all the stratified rocks from volcanic ejections, an absurdity which his opponents took care to expose, especially Vito Amici. Morrow seems to have been misled by his anxious desire to represent the formation of secondary rocks as having occupied an extremely short period, while at the same time he wished to employ known agents in nature. To imagine torrents, rivers, currents, partial floods, and all the operations of moving water to have gone on exerting an energy many thousands of times greater than at present would have appeared preposterous and incredible, and would have required 100 violent hypotheses. But we are so unacquainted with the true sources of subterranean disturbances that their former violence may in theory be multiplied indefinitely, without its being possible to prove the same manifest contradiction or absurdity in the conjecture. For this reason, perhaps, Morrow preferred to derive the materials of the strata from volcanic ejections rather than from transportation by running water. Marsili, whose work is alluded to by Generali, had been prompted to institute inquiries into the bed of the Adriatic by discovering in the territory of Parma, what Spada had observed near Verona and Schiavo in Sicily, that fossil shells were not scattered through the rocks at random, but disposed in regular order according to certain genera and species. Vitaliano Donati, 1750. But with a view of throwing further light upon these questions, Donati, in 1750, undertook a more extensive investigation of the Adriatic, and discovered by numerous soundings that deposits of sand, marl, and tufaceous incrustations, most strictly analogous to those of the sub-Apennine hills, were in the act of accumulating there. He ascertained that there were no shells in some of the submarine tracts, while in other places they lived together with families, particularly the genera Arca, Pecten, Venus, Murex, and some others. He also states that in divers localities he found a mass composed of corals, shells, and crustaceous bodies of different species, confusedly blended with earth, sand, and gravel. At the depth of a foot or more, the organic substances were entirely petrified and reduced to marble. At less than a foot from the surface, they approached nearer to their natural state, while at the surface they were alive or, if dead, in a good state of preservation. Baldassari. A contemporary naturalist, Baldassari, had shown that the organic remains in the tertiary marls of the Sienese territory were grouped in families, in a manner precisely similar to that above alluded to by Donati. Buffon, 1749. Buffon first made known his theoretical views concerning the former changes of the earth in his Natural History, published in 1749. He adopted the theory of an original volcanic nucleus, together with the universal ocean of Leibniz. By this aqueous envelope, the highest mountains were once covered. Marine currents then acted violently and formed horizontal strata by washing away solid matter in some parts and depositing it in others. They also excavated deep submarine valleys. The level of the ocean was then depressed by the entrance of a part of its waters into subterranean caverns, and thus some land was left dry. Buffon seems not to have profited, like Leibniz and Morrow, by the observations of Steno, or he could not have imagined that the strata were generally horizontal, and that those which contain organic remains had never been disturbed since the era of their formation. He was conscious of the great power annually exerted by rivers and marine currents in transporting earthy materials to lower levels, and he even contemplated the period when they would destroy all the present continents. Although in geology he was not an original observer, his genius enabled him to render his hypothesis attractive, and by the eloquence of his style and the boldness of his speculations he awakened curiosity and provoked a spirit of inquiry amongst his countrymen. Soon after the publication of his Natural History, in which was included his theory of the earth, he received an official letter, dated January 1751, from the Sorbonne, or Faculty of Theology in Paris, informing him that 14 propositions in his works, quote, were reprehensible and contrary to the creed of the Church, end quote. The first of these obnoxious passages, and the only one relating to geology, was as follows. Quote, the waters of the sea have produced the mountains and valleys of the land. The waters of the heavens, reducing all to level, will at last deliver the whole land over to the sea, and the sea, successively prevailing over the land, will leave dry new continents like those which we inhabit, end quote. Buffon was invited by the college, in very courteous terms, to send in an explanation, or rather a recantation, of his unorthodox opinions. To this he submitted, and a general assembly of the faculty having approved his, quote, declaration, end quote, he was required to publish it in his next work. The document begins with these words, quote, I declare that I had no intention to contradict the text of Scripture, and I believe most firmly all therein related about the creation, both as to order of time and matter of fact, and I abandon everything in my book respecting the foundation of the earth, and, generally, all which may be contrary to the narration of Moses, end quote. The grand principle which Buffon was called upon to renounce was simply this, that the present mountains and valleys of the earth are due to secondary causes, and that the same causes will in time destroy all the continents, hills, and valleys, and reproduce others like them. Now, whatever may be the defects of his many views, it is no longer controverted that the present continents are of secondary origin. The doctrine is as firmly established as the earth's rotation on its axis, and that the land, now elevated above the level of the sea, will not endure forever, is an opinion which gains ground daily, in proportion as we enlarge our experience of the changes now in progress. Targioni, 1751. Targioni, in his voluminous Travels in Tuscany, 1751 and 1754, labored to fill up the sketch of the geology of that region left by Steno 60 years before. Notwithstanding a want of arrangement and condensation in his memoirs, they contained a rich store of faithful observations. He was not indulged in many general views, but in regard to the origin of valleys, he was opposed to the theory of Buffon, who attributed them principally to submarine currents. The Tuscan naturalists labored to show that both the larger and smaller valleys of the Apennines were excavated by rivers and floods, caused by the bursting of the barriers of lakes after the retreat of the ocean. He also maintained that the elephants and other quadrupeds, so frequent in the lacustrine and alluvial deposits of Italy, had inhabited the peninsula, and had not been transported thither, as some had conceived, by Hannibal or the Romans, nor by what they were pleased to term, quote, a catastrophe of nature, end quote. Lehmann, 1756. In the year 1756, the treatise of Lehmann, a German mineralogist and director of the Prussian mines, appeared, who also divided mountains into three classes. The first, those formed with the world, and prior to the creation of animals, and which contained no fragments of other rocks. The second class, those which resulted from the partial destruction of the primary rocks by a general revolution, and a third class resulting from local revolutions and in part from the deluge of Noah. A French translation of his work appeared in 1759, on the preface of which the translator displays very enlightened views respecting the operations of earthquakes, as well as of the aqueous causes. Gessner, 1758. In this year, Gessner, the botanist of Zurich, published an excellent treatise on petrifications and the changes of the earth which they testify. After a detailed enumeration of the various classes of fossils of the animal and vegetable kingdoms, and remarks on the different states in which they are found petrified, he considers the geological phenomena connected with them, observing that some, like those of Oeningen, resembled the testacea, fish, and plants indigenous in the neighboring region, while some, such as ammonites, graphites, belemnites, and other shells, are either of unknown species or found only in the Indian and other distant seas. In order to elucidate the structure of the earth, he gives sections from Verenius, Buffon, and others, obtained in digging wells, distinguishes between horizontal and inclined strata, and in speculating on the causes of these appearances, mentions Donati's examination of the bed of the Adriatic, the filling up of lakes and seas by sediment, the embedding of shells now in progress, and many known effects of earthquakes, such as the sinking down of districts, or the heaving up of the bed of the sea, so as to form new islands and lay dry strata containing petrifactions. The ocean, he says, deserts its shores in many countries, as on the borders of the Baltic, but the rate of recession has been so slow in the last 2,000 years that to allow the Apennines, whose summits are filled with marine strata, to emerge at their present height would have required about 80,000 years, a lapse of time 10 times greater, or more, than the age of the universe. We must therefore refer the phenomenon to the command of the deity related by Moses that, quote, the waters should be gathered together in one place and the dry land appear, end quote. Gessner adopted the views of Leibniz to account for the retreat of the primeval ocean. His essays display much erudition, and the opinions of preceding writers of Italy, Germany, and England are commented upon with fairness and discrimination. Arduino, 1759. In the following year, Arduino, in his memoirs on the mountains of Padua, Vicenza, and Verona, deduced from original observation the distinction of rocks into primary, secondary, and tertiary, and showed that in these districts there had been a succession of submarine volcanic eruptions. Michel, 1760. In the following year, 1760, the Reverend John Michel, Woodwardian professor of mineralogy at Cambridge, published in the Philosophical Transactions an essay on the cause and phenomena of earthquakes. His attention had been drawn to this subject by the great earthquake of Lisbon in 1755. He advanced many original and philosophical views respecting the propagation of subterranean movements and the caverns and fissures wherein steam might be generated. In order to point out the application of his theory to the structure of the globe, he was led to describe the arrangement and disturbance of the strata, their usual horizontality in low countries, and their contortions and fractured state in the neighborhood of mountain chains. He also explained with surprising accuracy the relations of the central ridges of older rocks to the, quote, long narrow slips of similar earth, stones, and minerals, end quote, which are parallel to these ridges. In his generalizations, derived in great part from his own observations on the geological structure of Yorkshire, he anticipated many of the views more fully developed by later naturalists. Cathcart, 1761. Michel's papers were entirely free from all physico-theological disquisitions, but some of his contemporaries were still earnestly engaged in defending or impugning the Woodwardian hypothesis. We find many of these writings referred to by Cathcart, a Hutchinsonian, who published a treatise on the deluge in 1761. He labored particularly to refute an explanation offered by his contemporary Bishop Clayton of the Mosaic writings. That prelate had declared that the deluge, quote, could not be literally true, save in respect to the part where Noah lived before the flood, end quote. Cathcart insisted on the universality of the deluge and referred to traditions of inundations mentioned by ancient writers or by travelers in the East Indies, China, South America, and other countries. This part of his book is valuable, though it is not easy to see what bearing the traditions have, if admitted to be authentic, on the bishop's argument, since no evidence is adduced to prove that the catastrophes were contemporaneous events, while some of them are expressly represented by ancient authors to have occurred in succession. Fortis Odoardi, 1761. The doctrines of Arduino, above adverted to, were afterwards confirmed by Fortis and Desmarest in their travels in the same country, and they, as well as Baldassari, labored to complete the history of the sub-Apennine strata. In the work of Odoardi, there is also a clear argument in favor of the distinct ages of older Apennine strata and the sub-Apennine formations of more recent origin. He pointed out that the strata of these two groups were unconformable, and must have been the deposits of different seas at distant periods of time. Raspe, 1763. A History of the New Islands by Raspe, a Hanoverian, appeared in 1763 in Latin. In this work, all the authentic accounts of earthquakes which had produced permanent changes on the solid parts of the earth were collected together and examined with judicious criticism. The best systems which had been proposed concerning the ancient history of the globe, both by ancient and modern writers, are reviewed, and the merits and defects of the doctrines of Hooke, Ray, Moreau, Buffon, and others fairly estimated. Great admiration is expressed for the hypothesis of Hooke, and his explanation of the origin of the strata is shown to have been more correct than Moreau's, while their theory of the effects of earthquakes was the same. Raspe had not seen Michel's memoirs, and his views concerning the geological structure of the earth were perhaps less enlarged, yet he was able to add many additional arguments in favor of Hooke's theory, and to render it, as he said, a nearer approach to what Hooke would have written had he lived in later times. As to the periods wherein all the earthquakes happened, to which we owe the elevation of various parts of our continents and islands, Raspe says he pretends not to assign their duration, still less to defend Hooke's suggestion that the convulsions almost all took place during the deluge of Noah. He adverts to the apparent indications of the former tropical heat of the climate of Europe, and the changes in the species of animals and plants as among the most obscure and difficult problems in geology. In regard to the islands raised from the sea, within the times of history or tradition, he declares that some of them were composed of strata containing organic remains, and that they were not, as Buffon had asserted, made of mere volcanic matter. His work concludes with an eloquent exhortation to naturalists to examine the isles which rose in 1707 in the Grecian archipelago and in 1720 in the Azores, and not to neglect such splendid opportunities of studying nature, quote, in the act of parturition, end quote. That Hooke's writings should have been neglected for more than half a century was matter of astonishment to Raspe, but it was still more wonderful that his own luminous exposition of that theory should, for more than another half-century, have excited so little interest. Fuchsel, 1762 and 1773. Fuchsel, a German physician, published in 1762 a geological description of the country between the Thuringerwald and the Harz, and a memoir on the environs of Rudolstadt, and afterwards in 1773 a theoretical work on the ancient history of the earth and man. He had evidently advanced considerably beyond his predecessor Lehmann, and was aware of the distinctness both as to the position and fossil contents of several groups of strata of different ages, corresponding to the secondary formations now recognized by geologists in various parts of Germany. He supposed the European continents to have remained covered by the sea until the formation of the marine strata, called in Germany Muschelkalk, at the same time with the terrestrial plants of many European deposits, attested the existence of dry land which bordered the ancient sea, land which, therefore, must have occupied the place of the present ocean. The pre-existing continent had been gradually swallowed up by the sea, different parts having subsided in succession into subterranean caverns. All the sedimentary strata were originally horizontal, and their present state of derangement must be referred to subsequent oscillations of the ground. As there were plants and animals in the ancient periods, so also there must have been men, but they did not all descend from one pair, but were created at various points on the earth's surface, and the number of those distinct birthplaces was as great as are the original languages of nations. In the writings of Fuchsel, we see a strong desire manifested to explain geological phenomena as far as possible by reference to the agency of known causes, and although some of his speculations were fanciful, his views coincide much more nearly with those now generally adopted than the theories afterwards promulgated by Werner and his followers. Brander, 1766. Gustavus Brander published in 1766 his Fossilia Hantoniensia, containing excellent figures of fossil shells from the more modern, or Eocene, marine strata of Hampshire. He says in the preface, quote, "Various opinions had been entertained concerning the time when and how these bodies became deposited. Some there are who conceive that it might have been effected in a wonderful length of time by a gradual changing and shifting of the sea," end quote, etc. But the most common cause assigned is that of, quote, "the deluge," end quote. This conjecture, he says, even if the universality of the flood be not called in question, is purely hypothetical. In his opinion, fossil animals and testacea were, for the most part, of unknown species, and of such as were known, the living analogues now belong to southern latitudes. Soldani, 1780. Soldani applied successfully his knowledge of zoology to illustrate the history of stratified masses. He explained that microscopic testacea and zoophytes inhabited the depths of the Mediterranean, and that the fossil species were, in like manner, found in those deposits, wherein the fineness of their particles and the absence of pebbles implied that they were accumulated in a deep sea or far from shore. The author first remarked the alternation of marine and freshwater strata in the Paris basin. Fortis Testia, 1793. A lively controversy arose between Fortis and another Italian naturalist, Testa, concerning the fish of Monte Bolcia in 1793. Their letters, written with great spirit and elegance, show that they were aware that a large proportion of the sub-Apennine shells were identical with living species, and some of them with species now living in the torrid zone. Fortis proposed a somewhat fanciful conjecture that when the volcanoes of the Vicentin were burning, the waters of the Adriatic had a higher temperature, and in this matter, he said, the shells of warmer regions may once have peopled their own seas. But Testia was disposed to think that these species of testacea were still common to their own and to equinoctial seas. For many, he said, once supposed to be confined to hotter regions, had been afterwards discovered in the Mediterranean. Cortesi, Spallanzani, Valerius, Whitehurst. While these Italian naturalists, together with Cortesi and Spallanzani, were busily engaged in pointing out the analogy between the deposits of modern and ancient seas and the habits and arrangement of their organic inhabitants, and while some progress was making in the same country in investigating the ancient and modern volcanic rocks, some of the most original observers among the English and German writers, Whitehurst and Valerius, were wasting their strength in contending, according to the old Woodwardian hypothesis, that all the strata were formed by Noah's deluge. But Whitehurst's description of the rocks of Derbyshire was most faithful, and he atoned for false theoretical views by providing data for their refutation. Pallas Saussure. Towards the close of the 18th century, the idea of distinguishing the mineral masses on our globe into separate groups and studying their relations began to be generally diffused. Pallas and Saussure were among the most celebrated whose labors contributed to this end. After an attentive examination of the two great mountain chains of Siberia, Pallas announced the result that the granitic rocks were in the middle, the schistose at their sides, and the limestones again on the outside of these. And this, he conceived, could prove a general law in the formation of all chains composed chiefly of primary rocks. In his Travels in Russia in 1793 and 1794, he made many geological observations on the recent strata near Volga and the Caspian, and adduced proofs of the greater extent of the latter sea at no distant era in the Earth's history. His memoir on the fossil bones of Siberia attracted attention to some of the most remarkable phenomena in geology. He stated that he had found a rhinoceros entire in the frozen soil, with its skin and flesh. An elephant, found afterwards in a mass of ice on the shore of the North Sea, removed all doubt as to the accuracy of so wonderful a discovery. The subjects relating to natural history which engaged the attention of Pallas were too multifarious to admit of his devoting a large share of his labors exclusively to geology. Saussure, on the other hand, employed the chief portion of his time in studying the structure of the Alps and Jura, and he provided valuable data for those who followed him. He did not pretend to deduce any general system from his numerous and interesting observations, and the few theoretical opinions which escaped from him seem, like those of Pallas, to have been chiefly derived from the cosmological speculations of preceding writers. Chapter 4. History of the Progress of Geology. Continued. Werner. The art of mining has long been taught in France, Germany, and Hungary in scientific institutions established for that purpose, where mineralogy has always been a principal branch of instruction. Werner was named in 1775 a professor of that science in the School of Mines at Freiburg in Saxony. He directed his attention not merely to the composition and external characters of minerals, but also to what he termed geognosy, or the natural position of minerals in particular rocks, together with the grouping of those rocks, their geographical distribution, and various relations. The phenomena observed in the structure of the globe had hitherto served for little else than to furnish interesting topics for philosophical discussion, but when Werner pointed out their application to the practical purposes of mining, they were instantly regarded by a large class of men as an essential part of their professional education, and from that time the science was cultivated in Europe more ardently and systematically. Werner's mind was at once imaginative and richly stored with miscellaneous knowledge. He associated everything with his favorite science, and in his excursive lectures he pointed out all the economical uses of minerals and their applications to medicine, the influence of the mineral composition of rocks upon the soil, and the soil upon the resources, wealth, and civilization of man. The vast sandy plains of Tartary and Africa, he would say, retain their inhabitants in the shape of wandering shepherds. The granitic mountains and the low calcareous and alluvial plains gave rise to different manners, degrees of wealth, and intelligence. The history even of languages and the migration of tribes had been determined by the direction of particular strata. The qualities of certain stones used in building would lead him to descant on the architecture of different ages and nations, and the physical geography of a country frequently invited him to treat of military tactics. The charm of his manners and his eloquence kindled enthusiasm in the minds of his pupils, and many, who had intended at first only to acquire a slight knowledge of mineralogy, when they had once heard him, devoted themselves to it as the business of their lives. In a few years, a small school of mines, before unheard of in Europe, was raised to the rank of a great university, and men already distinguished in science studied the German language, and came from the most distant countries to hear the great oracle of geology. Werner had a great antipathy to the mechanical labor of writing, and with the exception of a valuable treatise on metalliferous veins, he could never be persuaded to pen more than a few brief memoirs, and those containing no development of his general views. Although the natural modesty of his disposition was excessive, approaching even to timidity, he indulged in the most bold and sweeping generalizations, and he inspired all his scholars with the most implicit faith in his doctrines. Their admiration of his genius, and the feelings of gratitude and friendship which they felt for him, were not undeserved. But the supreme authority usurped by him over the opinions of his contemporaries was eventually prejudicial to the progress of the science, so much so as greatly to counterbalance the advantages which it derived from his exertions. If it be true that delivery be the first, second, and third requisite in a popular orator, it is no less certain that to travel is of first, second, and third importance to those who desire to originate just and comprehensive views concerning the structure of our globe. Now Werner had not traveled to distant countries, he had merely explored a small portion of Germany, and conceived and persuaded others to believe that the whole surface of our planet and all the mountain chains in the world were made after the model of his own province. It became a ruling object of ambition in the minds of his pupils to confirm the generalizations of their great master, and to discover in the most distant parts of the globe his, quote, universal formations, end quote, which he supposed had been each in succession simultaneously precipitated over the whole earth from a common menstruum, or, quote, chaotic fluid, end quote. It now appears that the Saxon professor had misinterpreted many of the most important appearances even in the immediate neighborhood of Freiburg. Thus, for example, within a day's journey of his school, the porphyry, called by him primitive, has been found not only to send forth veins or dikes through strata of the coal formation, but to overlie them in mass. The granite of the Harz Mountains, on the other hand, which he supposed to be the nucleus of the chain, is now well known to traverse the other beds, as near Goslar, and still nearer Freiburg, in the Erzgebirge, the mica slate does not mantle round the granite as was supposed, but abuts abruptly against it. Fragments also of the grey wacky slate, containing organic remains, have recently been found entangled in the granite of the Harz by M. de Seckendorf. The principal merit of Werner's system of instruction consisted in steadily directing the attention of his scholars to the constant relations of superposition of certain mineral groups, but he had been anticipated, as has been shown in the last chapter, in the discovery of this general law by several geologists in Italy and elsewhere, and his leading divisions of the secondary strata were at the same time and independently made the basis of an arrangement of the British strata by our countryman William Smith, to whose work I shall refer in the sequel. Controversy between the volcanists and Neptunists. In regard to basalt and other igneous rocks, Werner's theory was original, but it was also extremely erroneous. The basalts of Saxony and Hesse, to which his observations were chiefly confined, consisted of tabular masses capping the hills and not connected with the levels of existing valleys, like many in the Auvergne and Vivarais. These basalts, and like all other rocks of the same family in other countries, were, according to him, chemical precipitates from water. He denied that they were the products of submarine volcanoes, and even taught that, in the primeval ages of the world, there were no volcanoes. His theory was opposed, in a twofold sense, to the doctrine of the permanent agency of the same causes in nature. For not only did he introduce, without scruple, many imaginary causes supposed to have once effected great revolutions in the earth, and then to have become extinct, but new ones were also fain to have come into play in modern times, and above all, that most violent instrument of change, the agency of subterranean heat. So early as 1768, before Werner had commenced his mineralogical studies, Raspe had truly characterized the basalts of Hesse as of igneous origin. Arduino, we have seen, had pointed out numerous varieties of trap rock in the Vicentin as analogous to volcanic products, and as distinctly referable to ancient submarine eruptions. Desmarest, as before stated, had in company with Fortis examined the Vicentin in 1766 and confirmed Arduino's views. In 1772, Banks, Solander, and Troyle compared the columnar basalt of Hecla with that of the Hebrides. Collini, in 1774, recognized the true nature of the igneous rocks on the Rhine between Andernach and Bonn. In 1775, Guettard visited the Vivarais and established the relation of basaltic currents to lavas. Lastly, in 1779, Faujas published his description of the volcanoes of the Vivarais and Velay, and showed how the streams of basalt had poured out from craters which still remain in a perfect state. Desmarest. When sound opinions had thus for 20 years prevailed in Europe concerning the true nature of the ancient trap rocks, Werner by his simple dictum caused a retrograde movement, and not only overturned the true theory, but substituted for it one of the most unphilosophical that can well be imagined. The continued ascendancy of his dogmas on this subject was the more astonishing because a variety of new and striking facts were daily accumulated in favor of the correct opinions previously entertained. Desmarest, after a careful examination of the Auvergne, pointed out, first, the most recent volcanoes which had their craters still entire, and their streams of lava conforming to the level of the present river courses. He then showed that there were others of an intermediate epoch whose craters were nearly effaced, and whose lavas were less intimately connected with the present valleys, and lastly, that there were volcanic rocks still more ancient, without any discernible craters or scoriae, and bearing the closest analogy to rocks in other parts of Europe, the igneous origin of which was denied by the school of Freiburg. Desmarest's map of Auvergne was a work of uncommon merit. He first made a trigonometrical survey of the district and delineated its physical geography with minute accuracy and admirable geographic power. He contrived at the same time to express without the aid of colors many geological details, including the different ages and sometimes even the structure of the volcanic rocks, and distinguishing them from the freshwater and the granitic. They alone who have carefully studied Auvergne and traced the different lava streams from their craters to their termination, the various isolated basaltic cappings, the relation of some lavas to the present valleys, the absence of such relation in others, can appreciate the extraordinary fidelity of this elaborate work. No other district of equal dimensions in Europe exhibits, perhaps, so beautiful and varied a series of phenomena, and, fortunately, Desmarest possessed at once the mathematical knowledge required for the construction of a map, skill in mineralogy, and a power of original generalization. Dolomieu Montlosier. Dolomieu, another of Werner's contemporaries, had found prismatic basalt among the ancient lavas of Etna. and in 1784 had observed the alternations of submarine lavas and calcareous strata in the Val di Noto in Sicily. In 1790, also, he described similar phenomena in the Vicentin and in the Tyrol. Montlosier published in 1788 an essay on the theories of volcanoes of the Auvergne, combining accurate local observations with comprehensive views. Notwithstanding this mass of evidence, the scholars of Werner were prepared to support his opinions to their utmost extent, maintaining in the fullness of their faith that even obsidian was an aqueous precipitate. As they were blinded by their veneration for the great teacher, they were impatient of opposition, and soon imbibed the spirit of a faction, and their opponents, the volcanists, were not long in becoming contaminated with the same intemperate zeal. Ridicule and irony were weapons more frequently employed than arguments by the rival sects, till at last the controversy was carried on with a degree of bitterness almost unprecedented in questions of physical science. Desmarest alone, who had long before provided ample materials for refuting such a theory, kept aloof from this strife, and whenever a zealous Neptunist wished to draw the old man into an argument, he was satisfied with replying, quote, "Go and see," end quote. Hutton, 1788. It would be contrary to all analogy in matters of graver import that a war should rage with such fury on the continent, and that the inhabitants of our island should not mingle in the affray. Although in England the personal influence of Werner was wanting to stimulate men to the defense of the weaker side of the question, they contrived to find good reason for espousing the Wernerian errors with great enthusiasm. In order to explain the peculiar motives which led many to enter, even with party feeling, into this contest, it will be necessary to present the reader with a sketch of the views unfolded by Hutton, a contemporary of the Saxon geologist. The former naturalist had been educated as a physician, but declining the practice of medicine, he resolved when young to remain content with the small independence inherited from his father, and thenceforth to give his undivided attention to scientific pursuits. He resided at Edinburgh, where he enjoyed the society of many men of high attainments, who loved him for the simplicity of his manners and the sincerity of his character. His application was unwearied, and he made frequent tours through different parts of England and Scotland, acquiring considerable skill as a mineralogist and consequently arriving at grand and comprehensive views in geology. He communicated the results of his observations unreservedly, and with the fearless spirit of one who was conscious that love of truth was the sole stimulus of his exertions. When at length he had matured in his views, he published in 1788 his Theory of the Earth, and the same afterwards more fully developed in a separate work in 1795. This treatise was the first in which geology was declared to be in no way concerned about, quote, questions as to the origin of things, end quote. The first in which an attempt was made to dispense entirely with all hypothetical causes and to explain the former changes of the Earth's crust by reference exclusively to natural agents. Hutton labored to give fixed principles to geology, as Newton had succeeded in doing to astronomy. But in the former science, too little progress had been made towards furnishing the necessary data to enable the philosopher, however great his genius, to realize so noble a project. Huttonian theory. Said Hutton, quote, "The ruins of an older world are visible in the present structure of our planet, and the strata which now compose our continents have been once beneath the sea and were formed out of the waste of pre-existing continents. The same forces are still destroying, by chemical composition or mechanical violence, even the hardest rocks, and transporting the materials to the sea, where they are spread out and form strata analogous to those of more ancient date. Although loosely deposited along the bottom of the ocean, they become afterwards altered and consolidated by volcanic heat, and then heaved up, fractured, and contorted." End quote. Although Hutton had never explored any region of active volcanoes, he had convinced himself that basalt and many other trap rocks were of igneous origin, and that many of them had been injected in a melted state through fissures in older strata. The compactness of these rocks and their different aspect from that of ordinary lava he attributed to their having cooled down under the pressure of the sea, and in order to remove the objections started against this theory, his friend Sir James Hall instituted a most curious and instructive series of chemical experiments, illustrating the crystalline arrangement and texture assumed by melted matter cooled under high pressure. The absence of stratification in granite, and its analogy in mineral character to rocks which he deemed of igneous origin, led Hutton to conclude that granite must also have been formed from matter in fusion. And this inference he felt could not be fully confirmed unless he discovered at the contact of granite and other strata a repetition of the phenomena exhibited so constantly by the trap rocks. Resolved to try his theory by this test, he went to the Grampians and surveyed the line of junction of the granite and superincumbent stratified masses until he found in Glen Tilt in 1785 the most clear and unequivocal proofs in support of his views. Veins of red granite are there seen branching out from the principal mass and traversing the black micaceous schist and primary limestone. The intersected stratified rocks are so distinct in color and appearance as to render the example in that locality most striking, and the alteration of the limestone in contact was very analogous to that produced by trap veins on calcareous strata. This verification of his system filled him with delight, and called forth such marks of joy and exultation that the guides who accompanied him, says his biographer, were convinced that he must have discovered a vein of silver or gold. He was aware that the same theory would not explain the origin of the primary schists, but these he called primary, rejecting the term primitive, and was disposed to consider them as sedimentary rocks altered by heat, and that they originated in some other form from the waste of the previously existing rocks. By this important discovery of granite veins, to which he had been led by fair induction from an independent class of facts, Hutton prepared the way for the greatest innovation of the systems of his predecessors. Vallis Neri had pointed out the general fact that there were certain fundamental rocks which contained no organic remains, and which he supposed to have been formed before the creation of living beings. Moro, Generelli, and other Italian writers embraced the same doctrine, and Lehmann regarded the mountains called by him primitive as parts of the original nucleus of the globe. The same tenet was an article of faith in the school of Freiburg, and if anyone ventured to doubt the possibility of our being enabled to carry back our researches to the creation of the present order of things, the granitic rocks were triumphantly appealed to. On them seemed written, in legible characters, the memorable inscription, quote, Denuntia me non fur cose create, se non eterne, end quote. And no small sensation was excited when Hutton seemed, with unhallowed hand, desirous to erase characters already regarded by many as sacred. Said the Scotch geologist, quote, In the economy of the world I can find no traces of a beginning, no prospect of an end, end quote. A declaration the more startling when coupled with the doctrine that all past ages on the globe had been brought by the slow agency of existing causes. The imagination was first fatigued and overpowered by endeavoring to conceive the immensity of time required for the annihilation of whole continents by so insensible a process. And when the thoughts had wandered through these interminable periods, no resting place was assigned in the remotest distance. The oldest rocks were presented to be of a derivative nature, the last of an antecedent series, and that, perhaps, one of the many pre-existing worlds. Such views of the immensity of past time, like those unfolded by the Newtonian philosophy in regard to space, were too vast to awaken ideas of sublimity unmixed with a painful sense of our incapacity to conceive a plan of such infinite extent. Worlds are seen beyond worlds immeasurably distant from each other, and beyond them all innumerable other systems are faintly traced on the confines of the visible universe. The characteristic feature of the Huttonian theory was, as before hinted, the exclusion of causes not supposed to belong to the present order of nature. But Hutton had made no step beyond Hooke, Morrow, and Rasp in pointing out in what manner the laws now governing subterranean movements might bring about geological changes, if sufficient time be allowed. On the contrary, he seems to have fallen far short of some of their views, especially when he refused to attribute any part of the external configuration of the Earth's crust to subsidence. He imagined that the continents were first gradually destroyed by aqueous degradation, and when their ruins had furnished materials for new continents, they were upheaved by violent convulsions. He therefore required alternate periods of general disturbance and repose, and such he believed had been, and would forever be, the course of nature. Generelli, in his exposition of Morrow's system, had made a far nearer approximation towards reconciling geological appearances with the state of nature as known to us. For while he agreed with Hutton that the decay and reproduction of rocks were always in progress, proceeding with the utmost uniformity, the learned Carmelite represented the repairs of mountains by elevation from below to be effected by an equally constant and synchronous operation. Neither of these theories, considered singly, satisfies with all conditions of the great problem, which a geologist who rejects cosmological causes is called upon to solve. But they probably contain, together, the germs of a perfect system. There can be no doubt that periods of disturbance and repose have followed each other in succession in every region of the globe, but it may be equally true that the energy of the subterranean movements has been always uniform as regards the whole Earth. The force of earthquakes may for a cycle of years have been invariably confined, as it is now, to large but determinate spaces, and may then have gradually shifted its position so that another region, which had for ages been at rest, become in its turn the grand theatre of action. Playfair's illustrations of Hutton. The explanation proposed by Hutton and by Playfair, the illustrator of his theory, respecting the origin of valleys and of alluvial accumulations, was also very imperfect. They ascribed none of the inequalities of the earth's surface to movements which accompanied the upheaving of the land, imagining that valleys in general were formed in the course of ages by the rivers now flowing in them, while they seem not to have reflected on the excavating and transporting power which the waves of the ocean might exert on land during its emergence. Although Hutton's knowledge of mineralogy and chemistry was considerable, he possessed but little information concerning organic remains. They merely served him, as they did Werner, to characterize certain strata, and to prove their marine origin. The theory of former revolutions in organic life was not yet fully recognized, and without this class of proofs in support of the antiquity of the globe, the indefinite periods demanded by the Huttonian hypothesis appeared visionary to many, and some who deemed the doctrine inconsistent with revealed truths indulged very uncharitable suspicions of the motives of its author. They accused him of deliberate design of reviving the heathen dogma of an, quote, eternal succession, end quote, and of denying that this world ever had a beginning. Playfair, in the biography of his friend, has the following comment on this part of their theory, quote, in the planetary motions, where geometry has carried the eye so far, both into the future and the past, we discover no mark either of the commencement or termination of the present order. It is unreasonable indeed to assume that such marks should anywhere exist. The author of nature has not given laws to the universe which, like the institutions of men, carry in themselves the elements of their own destruction. He has not permitted his works any symptom of infancy or of old age, or any sign by which we may estimate either their future or their past duration. He may put an end, as he no doubt gave a beginning, to the present system, at some determinate period of time. But we may rest assured that this great catastrophe will not be brought about by the laws now existing, and that it is not indicated by anything which we perceive. End quote. The party feeling excited against the Huttonian doctrines, and the open disregard of candor and temper in the controversy, will hardly be credited by the reader unless he recalls to his recollection that the mind of the English public was at the time in a state of feverish excitement. A class of writers in France had been laboring industriously for many years to diminish the influence of the clergy by sapping the foundations of the Christian faith, and their success and the consequences of the revolution had alarmed the most resolute minds, while the imagination of the more timid was continually haunted by dread of innovation, as by the phantom of some fearful dream. Voltaire. Voltaire had used the modern discoveries in physics as one of the numerous weapons of attack and ridicule directed by him against the Scriptures. He found that the most popular systems of geology were accommodated to the sacred writings, and that much ingenuity had been employed to make every fact coincide exactly with the Mosaic account of the creation and deluge. It was, therefore, no friendly feelings that he contemplated the cultivators of geology in general, regarding the science as one which had been successfully enlisted by theologians as an ally in their cause. He knew that the majority of those who were aware of the abundance of fossil shells in the interior of continents were still persuaded that they were proofs of the universal deluge, and as the readiest way of shaking this article of faith, he endeavored to inculcate skepticism as to the real nature of such shells, and to recall from contempt the exploded dogma of the 16th century that they were sports of nature. He also pretended that vegetable impressions were not those of real plants, yet he was perfectly convinced that the shells had really belonged to living testacea, as may be seen in his essay on the formation of mountains. He would sometimes, in defiance of all consistency, shift his ground when addressing the vulgar, and, admitting the true nature of the shells collected in the Alps and other places, pretend that they were eastern species, which had fallen from the hats of pilgrims coming from Syria. The numerous essays written by him on geological subjects were all calculated to strengthen prejudices, partly because he was ignorant of the real state of the science, and partly from his bad faith. On the other hand, they who knew that his attacks were directed by a desire to invalidate Scripture, and who were unacquainted with the true merits of the question, might well deem the old Diluvian hypothesis incontrovertible, if Voltaire could adduce no better argument against it than to deny the true nature of organic remains. It is only by careful attention to impediments originating in extrinsic causes that we can explain the slow and reluctant adoption of the simplest truths in geology. First, we find many able naturalists adducing the fossil remains of marine animals as proofs of an event related in Scripture. The evidence is deemed conclusive by the multitude for a century or more, for it favors opinions which they entertained before, and they are gratified by supposing them confirmed by fresh and unexpected proofs. Many who see through the fallacy have no wish to undeceive those who are influenced by it, approving the effect of the delusion, and conniving at it as a pious fraud, until, finally, an opposite party who are hostile to the sacred writings labor to explode the erroneous opinion by substituting for it another dogma which they know to be equally unsound. The heretical Vulcanists were soon after openly assailed in England by imputations of the most illiberal kind. We cannot estimate the malevolence of such a persecution by the pain which similar insinuations might now inflict, for although charges of infidelity and atheism must always be odious, they were injurious in the extreme at the moment of political excitement, and it was better, perhaps, for a man's good reception in society that his moral character should have been traduced than that he should become a mark for these poisoned weapons. I shall pass over the works of numerous divines who may be excused for sensitiveness on points which then excited so much uneasiness in the public mind, and shall say nothing of the amiable poet Cowper, who could hardly be expected to have inquired into the merit of doctrines in physics. But in the foremost ranks of the intolerant are found several laymen who had high claims to scientific reputation. Among these appears Williams, a mineral surveyor of Edinburgh, who published a Natural History of the Mineral Kingdom in 1789, a work of great merit for that day and of practical utility as containing the best account of the coal strata. In his preface, he misrepresents Hutton's theory altogether, and charges him with considering all rocks to be lavas of different colors and structure, and also with, quote, warping everything to support the eternity of the world, end quote. He descants on the pernicious influence of the skeptical notions as leading to downright infidelity and atheism, quote, and as being nothing less than to depose the almighty creator of the universe from his office, end quote. Curwan de Luc. Curwan, president of the Royal Academy of Dublin, a chemist and mineralogist of some merit, but who possessed much greater authority in the scientific world than he was entitled by his talents to enjoy, said in the introduction of his Geological Essays 1799, quote, that sound geology graduated into religion and was required to dispel certain systems of atheism or infidelity of which they had recent experience, end quote. He was an uncompromising defender of the aqueous theory of all rocks, and was scarcely surpassed by Burnet and Whiston in his desire to adduce the Mosaic writings in confirmation of his opinions. De Luc, in the preliminary discourse to his treatise on geology, says, quote, the weapons have been changed by which revealed religion is attacked. It is now assailed by geology, and the knowledge of this science has become essential to theologians, end quote. He imputes the failure of former geological systems to their having been anti-Mosaical and directed against a, quote, sublime tradition, end quote. These and similar imputations, reiterated in the works of De Luc, seem to have been taken for granted by some modern writers. It is therefore necessary to state, in justice to the numerous geologists of different nations, whose works have been considered, that none of them were guilty of endeavoring, by arguments drawn from physics, to invalidate scriptural tenets. On the contrary, the majority of those who were fortunate enough, quote, to discover the true causes of things, end quote, rarely deserved another part of the poet's panegyric, quote, atque metus omnes subjectit pedibus, end quote. The caution and even timid reserve of many eminent Italian authors of the earlier period is very apparent, and there can hardly be a doubt that they were subscribed to certain dogmas and particularly to the first Diluvian theory out of deference to popular prejudices rather than from conviction. If they were guilty of dissimulation, we may feel regret, but must not blame their want of moral courage, reserving rather our condemnation for the intolerance of the times and that inquisitorial power which forced Galileo to abjure, and the two Jesuits to disclaim the theory of Newton. Hutton answered Kirwan's attacks with great warmth, and with the indignation justly excited by unmerited reproach. Says Playfair, quote, "He had always displayed the utmost disposition to admire the beneficent design manifested in the structure of the world, and he contemplated with delight those parts of his theory which made the greatest additions to our knowledge of final causes." End quote. We may say with equal truth that in no scientific works in our language can more eloquent passages be found concerning the fitness, harmony, and grandeur of all parts of the creation than those in Playfair. They are evidently the unaffected expressions of a mind which contemplated the study of nature as best calculated to elevate our conceptions of the attributes of the first cause. At any other time, the force and elegance of Playfair's style must have ensured popularity to the Huttonian doctrines, but by a singular coincidence, Neptunianism and orthodoxy were now associated in the same creed, and the tide of prejudice ran so strong that the majority were carried far away into the chaotic fluid and other cosmological inventions of Werner. These fictions the Saxon professor had borrowed with little modification, and without any improvement from his predecessors. They had not the smallest foundation either in Scripture or in common sense, and were probably approved of by many as being so ideal and unsubstantial that they could never come into violent collision with any preconceived opinions. According to De Luc, the first essential distinction to be made between the various phenomena exhibited on the surface of the earth was to determine which were the results of causes still in action and which had been produced by causes that had ceased to act. The form and composition of the mass of our continents, he said, and their existence above the level of the sea, must be ascribed to causes no longer in action. These continents emerged, at no very remote period, on the sudden retreat of the ocean, the waters of which made their way into subterranean caverns. The formation of the rocks which enter into the crust of the earth began with the precipitation of granite from a primordial liquid, after which other strata containing the remains of organized bodies were deposited, till at last the present sea remained as the residuum of the primordial liquid, and no longer continued to produce mineral strata. William Smith, 1790. While the tenets of the rival schools of Freiburg and Edinburgh were warmly espoused by devoted partisans, the labors of an individual, unassisted by the advantages of wealth or station in society, were almost unheeded. Mr. William Smith, an English surveyor, published his Tabular View of the British Strata in 1790, wherein he proposed a classification of the secondary formations in the west of England. Although he had not communicated with Werner, it appeared by his work that he had arrived at the same views respecting the laws of superposition of stratified rocks, that he was aware that the order of succession of different groups was never inverted, and that they might be identified at very distant points by their peculiar organized fossils. From the time of the appearance of the Tabular View, the author labored to construct a geological map of the whole of England, and with the greatest disinterestedness of mind communicated the results of his investigations to all who desired information, giving such publicity to his original views as to enable his contemporaries almost to compete with him in the race. The execution of his map was completed in 1815, and remains a lasting monument of original talent and extraordinary perseverance. For he had explored the whole country on foot without the guidance of previous observers or the aid of fellow laborers, and had succeeded in throwing into natural divisions the whole complicated series of British rocks. D'Aubusson, a distinguished pupil of Werner, paid a just tribute of praise to this remarkable performance, observing that, quote, "What many celebrated mineralogists had only accomplished for a small part of Germany in the course of half a century, had been effected by a single individual for the whole of England." End quote. Werner invented a new language to express his division of rocks, and some of his technical terms, such as greywacke, gneiss, and others, passed current in every country in Europe. Smith adopted for the most part English provincial terms, often of barbarous sound, such as gelt, cornbrash, clinch clay, and affixed them to subdivisions of the British series. Many of these still retain their place in our scientific classifications and attest his priority of arrangement. Modern progress of geology. The contention of the rival factions of the Vulcanists and Neptunists had been carried to such a height that these names had become terms of reproach, and the two parties had been less occupied in searching for truth than for such arguments as might strengthen their own cause or serve to annoy their antagonists. A new school at last arose who professed the strictest neutrality and the utmost indifference to the systems of Werner and Hutton, and who resolved diligently to devote their labors to observation. The reaction provoked by the intemperance of their conflicting parties now produced a tendency to extreme caution. Speculative views were discountenanced, and through fear of exposing themselves to the suspicion of a bias towards the dogmas of a party, some geologists became anxious to entertain no opinion whatever on the causes of phenomena, and were inclined to skepticism even where the conclusions deducible from observed facts scarcely admitted of reasonable doubt. Geological Society of London. But although the reluctance to theorize was carried somewhat to excess, no measure could be salutary at such a moment than a suspension of all attempts to form what were termed, quote, theories of the earth, end quote. A great body of new data were required, and the Geological Society of London, founded in 1807, conduced greatly to the attainment of this desirable end. To multiply and record observations, and patiently to await the result at some future period, was the object proposed by them, and it was their favorite maxim that the time was not yet come for a general system of geology, but that all must be content for many years to be exclusively engaged in furnishing materials for future generalizations. By acting up to these principles with consistency, they in a few years disarmed all prejudice and rescued the science from the imputation of being a dangerous, or at best but a visionary pursuit. A distinguished modern writer has with truth remarked that the advancement of three of the main divisions of geological inquiry have during the last half-century been promoted successively by three different nations of Europe, the Germans, the English, and the French. We have seen that the systematic study of what may be called mineralogical geology had its origin and chief point of activity in Germany, where Werner first described with precision the mineral characters of rocks. The classification of the secondary formations, each marked by their peculiar fossils, belongs in a great measure to England, where the labors before alluded to of Smith and those of the most active members of the Geological Society of London were steadily directed to these objects. The foundation of the third branch, that relating to the tertiary formations, was laid in France by the splendid work of Cuvier and Brongniart, published in 1808, on the mineral geography and organic remains of the neighborhood of Paris. We may still trace, in the language of the science and our present methods of arrangement, the various countries where the growth of these several departments of geology was at different times promoted. Many names of simple minerals and rocks remain to this day German, while the European divisions of the secondary strata are in great part English, and are, indeed, often founded too exclusively on English types. Lastly, the subdivisions first established of the succession of strata in the Paris Basin have served as normal groups to which other tertiary deposits throughout Europe have been compared, even in cases where this standard was wholly inapplicable. No period could have been more fortunate for the discovery in the immediate neighborhood of Paris of a rich store of well-preserved fossils than the commencement of the present century, for at no former era had natural history been cultivated with such enthusiasm in the French metropolis. The labors of Cuvier in comparative osteology and of Lamarck in recent and fossil shells had raised the departments of study to a rank in which they had never previously been deemed susceptible. Their investigations had eventually a profound effect on dispelling the illusion which had long prevailed concerning the absence of analogy between the ancient and modern state of our planet. A close comparison of the recent and fossil species and the inferences drawn in regard to their habits accustomed the geologist to contemplate the earth as having been at successive periods the dwelling place of animals and plants of different races, some terrestrial and others aquatic, some fitted to live in seas, others in the waters of lakes and rivers. By the consideration of these topics, the mind was slowly and insensibly withdrawn from imaginary pictures of catastrophes and chaotic confusion, such as haunted the imagination of the early cosmogonists. Numerous proofs were discovered of the tranquil deposition of sedimentary matter and the slow development of organic life. If many writers, and Cuvier himself in the number, still continued to maintain that, quote, the thread of induction was broken, end quote, yet, in reasoning by the strict rules of induction from recent to fossil species, they in a great measure disclaimed the dogma which in theory they professed. The adoption of the same generic, and in some cases even of the same specific, names for the exuviae of fossils and their living analogues, was an important step towards familiarizing the mind with the idea of the identity and unity of the system in distant eras. It was an acknowledgement, as it were, that part at least of the ancient memorials of nature were written in a living language. The growing importance, then, of the natural history of organic remains may be pointed out as the characteristic feature of the progress of the science during the present century. This branch of knowledge has already become an instrument of great utility in geological classification and is continuing daily to unfold new data for grand and enlarged views respecting the former changes of the Earth. When we compare the results of observations in the last 50 years with those of the 3 preceding centuries, we cannot but look forward to the most sanguine expectations to the degree of excellence to which geology may be carried, even by the labors of the present generation. Never, perhaps, did any science, with the exception of astronomy, unfold, in an equally brief period, so many novel and unexpected truths and overturn so many preconceived opinions. The senses had for ages declared the Earth to be at rest, until the astronomer taught that it was carried through space with inconceivable rapidity. In like manner was the surface of this planet regarded as having remained unaltered since its creation, until the geologist proved that it had been the theater of reiterated change, and was still the subject of slow but never-ending fluctuations. The discovery of other systems in the boundless regions of space was the triumph of astronomy. To trace the same system through various transformations, to behold it at successive eras adorned with different hills and valleys, lakes and seas, and peopled with new inhabitants, was the delightful meed of geological research. By the geometer were measured the regions of space and the relative distances of heavenly bodies. By the geologist, myriads of ages were reckoned, not by arithmetical computation, but by a train of physical events, a succession of phenomena in the animate and inanimate worlds, signs which convey to our minds more definite ideas than figures can do of the immensity of time. Whether our investigation of the Earth's history and structure will eventually be productive of as great practical benefits to mankind as a knowledge of the distant heavens must remain for the decision of posterity. It was not till astronomy had been enriched by the observations of many centuries and had made its way against popular prejudices to the establishment of a sound theory that its application to the useful arts was most conspicuous. The cultivation of geology began at a later period, and in every step which it has hitherto made towards sound theoretical principles, it had to contend against more violent prepossessions. The practical advantages already derived from it have not been inconsiderable, but our generalizations are yet imperfect, and they who come after us may be expected to reap the most valuable fruits of our labor. Meanwhile, the charm of first discovery is our own, and as we explore this magnificent field of inquiry, the sentiments of a great historian of our times may continually be present to our minds that, quote, "He who calls what has vanished back again into being enjoys a bliss like that of creating," end quote.